There's always something to see. You just need to open your eyes. And with that, as always, I mean Enek, who is running for safety right now. Hey, welcome. Nice to be here again. I was looking forward to this all week, especially since it's the only time I can basically work on this. And with this, I mean the Voron 2.0 that we started to build a couple of weeks ago. This is how far we got. By the way, let me know if you are annoyed by Doctor Who quotes at the beginning of the videos. Not sure if anybody even noticed that those are quotes. Definitely put that in the comments if you're annoyed. I'd so much like to hear from you. Also, again, to give people a bit of a chance to catch up, join here. Some recap. Again, streaming schedule, if you're not aware, is Saturdays from 7 to whatever, 3 to 4 hours. Central European time, or 6 p.m. to whenever we feel like concluding it on UK time. East Coast about 1 p.m. and West Coast about 9 a.m. Sorry, you guys. World is a big place. Many time zones. Be glad you have those. Otherwise, your days would be dark, or hours, depending on how that turns out. Yeah. To kick this off, I'd say let's start with a few things to recap on the stream itself. Most importantly, sorry for that one viewer that was in the chat during the last stream for the first couple of minutes, or rather more than half an hour. There seems to have been a bit of a problem that kept me from realizing that you're even there. If somebody joins, let me know. Definitely let me know that you're here. Post something in the chat. Let's have a bit of fun. On the topic of fun, I'm gonna hide the chat until people actually join. I will still monitor it on my end. I have a monitoring station set up here, monitoring screen. But yeah, let me know. Definitely let me know. Once we get a good chat going, I will definitely enable it again. We should also have a bot in chat now that will take care of a few minor things. Not sure if that's actually doing much, but we'll see. We'll see. Also, I hope I fixed the music volume. It was way too low last time after I started tinkering with it. I kind of tried to balance it out again. I hope I'm still well audible, otherwise this is going to suck very much when I watch it back later. And I noticed that I have been a bit too shorthand, so either ask me things now or after the video in the comments. Yeah. Again, just as a recap, chapters are still available. I also make clips available on the videos that I have been posting. To, for example, our Twitter and Discord, which I set up. If you want to interact with me, if you want to talk to me, if you have suggestions for the stream, if you have suggestions for anything we do here, anything I can do better, let me know. I definitely would love to hear from you. I would also very much appreciate it if you could like the stream, share it with anybody you deem might be interested in this, so we can maybe grow a community here and yeah, get a bit of a conversation going. That would be awesome. Yeah, join the Discord, follow on Twitter. You can find the links to that in the description below. Yeah, definitely gonna look at those and get back to you with any feedback, anything you wanna get off your chest. Yeah. General reminder, I tend to be very, let's say, on point with things I say. I may not always know what I'm saying, what I'm doing as much as I'd like to. So if you find fault in anything I say, anything I do, please let me know. Please let me know. I'm here to learn just as much as you are. Yeah. The only reason why I am this direct is because I do not ever want to be in a situation where there's any way out of something I said. So if I'm saying something wrong and you call bullshit, that is still very much appreciated. Yeah. In terms of the build, we are almost at the electronic stage. This time around we will get to the AB motors, belts, bed, but likely not mounting it because I did not prepare that in the last stream and it needs to sit for about 24 hours at least with a bit of weight on it, so it really sticks since we're not gonna silicone that down. Yeah, motors, toolhead, hopefully. I'm really looking forward to building that toolhead. I really want to see how that umbilical board goes in there, what it looks like in the end, and obviously see the cat ears in action. That would be awesome. Yeah, and while we're doing that, I do have a couple topics we can talk about. Some questions from people I know, some questions from people I've been interacting with, so yeah. That's the plan. All right, I'd say let's get into it. We're not going to start off with this. We are going to start off with preparing the bed. I already have a few things prepared here that I think we may need. This not so much, but the magnet on the back. There we go. And the first thing I realize is I should have grabbed the IPA. Give me a sec. Nope, that's not IPA, that's glass cleaner. Sniffing glass cleaner this early in the stream. Wow. Anyways, again, first things, doing the bed. Most important thing, I guess, for doing this correctly is to make sure your surfaces are clean, your surfaces are good. So you don't have any bubbles under them between your magnet or your heater and the bed itself. The bed itself feels quite quite rough of a surface, so I'm guessing the adhesive will adhere very well here. Let's move this aside. Let's see here. Yeah, and what we definitely want to do is just clean that with isopropyl alcohol real quick to get any grime, any oils off of it, so we get a better contact surface. We only need to do one side now, and the manual, if you remember from the first stream, we're gonna actually look at the place where that bed gets mounted. The manual actually says to mount the heater first. I don't think we're gonna do that. Let me see here. I think it's actually reasonably important that, yeah, here we go. It tells us what the top is, what the bottom is, and then it mounts the heater first. We're gonna mount the bed magnet first. So we'll need to look at what the top and bottom side actually are. And then we are going to do that first. And we're only gonna mount the heater and the... We're only gonna mount the heater and the magnet. We're not gonna do anything else. We're not gonna add the sensors or anything, the fuse. The side on the top is basically the one with the bigger holes, because that's where your screws come through. That's what we want to do first. So bed aside, and then let's look here real quick. Yeah, so if we just make sure that we start on the front edge very parallel, and you can't see shit. Let me switch you to the top there. No, that one. Let's take that one. All right, we're gonna try to do this as parallel as possible. We can actually use a block here. Put the bed against the block, and then we want to roll it on. And we want to move back and forth either with your thumbs or with a credit card or whatever else to make sure that every single piece or every single centimeter or you cover here to put this on does not have any bubbles under it. And there we go. It's not 100% straight, but I think it's going to be good enough. Yeah, that's definitely good enough. The other thing we're going to do right now is open up those holes so we can later screw into them. Well, actually, no, we're not. We're just going to leave it this way, and we can still open up those holes later. Clean it off. On the other side. And basically do the same thing for our bed. Now with the bed, it is important that we actually do this the right way around. We see here we have two holes on the back and one on the front. So that's how our bed needs to be aligned. The interesting thing here that I'm noticing is that we do not have any additional holes for the fuse. That's going to be a bit interesting because I think Fysetc actually wants us to use these additional holes, potentially. We can actually find out. Give me a sec. We may need to do this again, but No, they're actually using the holes there. So it would be interesting to know how they expect us to also mount the fuse. I'll have to check on that, but for the moment we don't care. We still have a bit to go. I may have touched that surface, so quick wipe down of the table as well, and then I will put this aside under a cushion and a bit of weight, so it really gets pushed down and really connects well. Again, one side as parallel as possible, as centered as possible, and then rolling it on, leaving as few possibilities for gaps and bubbles as possible. This is a bit harder to do with the heater than with the magnet, because the heater is not as flat, but this, I would say, looks pretty good. This actually looks really good. Yeah, I'm quite satisfied with that. Nice. That's the bed prepared. No big deal. Just for fun, we're already gonna. Well, actually, this is going to make our life harder if we put on the plate already. But yeah, we'll see. This is done for now, so I'm gonna put it aside. But now we have it for the next stream. All right, cool. Nice. So then I guess we can continue where we left off with our main printer build. And by the way, I can tell you, I have been so much looking forward to this. It is really hard to stop building and then wait for the next weekend. So I hope at some point at least somebody gets to appreciate that and appreciates that I'm still somewhat disciplined in this because it's really hard. It is you cannot imagine. You can really not imagine how much that takes out of me because I like building 3D printers. Cool. We're here. Let me give you a look at the manual. This is what we're working with. This is what we're looking at. Next step is, as you can see, assembling the AB motors, and we already did the heat set inserts, but let me grab the parts real quick. So these are these beautiful things, and we definitely need some screws and some tops. There we go. Look at that. These are so nice. These are so nice, and look at this color. It's gonna be such a beautiful printer. So the manual tells us we have an A side and a B side, and the A and B sides are marked. And I'm guessing they are also keyed. So this is the A side, this is the B side. That's probably, I'm gonna leave the tops like they are for now. Now we're asked to insert the heat sets below the surface. This is something we ignored when we first went through this through this manual. We're going to need to fix that. I'm also going to do some cleanup on the. I'm also going to do some cleanup on the edges while the insert press is heating up. Because there is an elephant's foot present, and I don't want it to. But of course, elephant's foot is better than not having a good first layer. So if you have a choice between a bit more squish, bit less squish, I would probably always opt for a bit more. Although, yeah, taste may vary. There we go. That's the first one. Let's give the soldering iron some more time to heat up here. And that's fine as well. I mean, the corners I am notoriously bad at cleaning up. Not sure if that's me or if that's the task of cleaning up corners. But yeah. These as well. I already went to configuration and would apply a bit less squish on the printer. But this is, by the way, the downside of running off your full parts list in one single fell swoop. Because problems you have, you will have on all your parts. So if you're a bit more patient than me, and I hope you are, because I'm not the most patient person in the world, yeah, maybe split it up a bit. Just saying. Yeah. Also, if you're thinking about building a 3D printer, but you're not sure if you can actually do it, do it. I have been avoiding manual building tasks most of my life. Most of my life I dealt with software, 3D design, programming, things like that. Some administrative tasks as well, computer administration, network administration. I actually built my own firewalls, but I have rarely had to deal with building something, even putting in bolts into walls and yeah, anything manual I try to avoid as much as possible for whatever reason, which means that I do not have the skill. I really do not have the skill. I do not have the common sense that others may think is required to do these. So I'm learning just as much as you are, if not more. And I am also not the most skilled person in the world, so just, yeah, if you're trying to build a 3D printer, just go for it. Just go for it. It's fun, no matter if you're good at it or not. Anyways, soldering iron seems to be hot, so let's put those heat sets down somewhat. Obviously, because of the way this is shaped on the bottom, I see that camera's a bit blown out. Let me see if I can actually do something about that. Nope, seems like not. Okay, you can still see it somewhat. By the way, why can't I? good. That should be better. Yeah, you see this lip, and that basically prevents us from having a good planar surface. So we're gonna grab our vise and put the thing in the vise, because obviously we want to do this as correctly as possible, I guess. Again, how would I know? I have no idea of how to do these manual things. I did start building my own bikes, as I hinted at, so bicycle bikes, mountain bikes, as I hinted at in a previous stream. So I may have picked up the odd tool here and there and the odd skill here and there, but in general I'm more a software and electronics guy, so I'm actually looking forward to getting into the electronics part very much, because I may have more to offer there than with me limping through this build. Which, by the way, reminds me, a friend of mine who is also building 3D printers actually asked me if I was going to use the Nitehawk Toolhead PCB anytime soon on a build, because I told him that I was going to go CAN on this one and on the solid fork as well. And I told him no. The reason being that while I do very much appreciate what LDO is doing for the community, for 3D printing and supplying kits, supplying all manner of support to streamers, I think they're not doing it correctly. They are providing a solution that doesn't have too many advantages over what we have with CAN. No matter whether you're using CAN or USB, you still need to run separate 24 volts. They opted for only running 24 volts, which is somewhat of an improvement, but they're still not using USB power delivery. And I think that's the actual future, because if you can use USB PD in a 3D printer, you have so many different voltages, so many different supplies available to you, provided you find a really crazy high-powered hub for your USB devices. That may be something to work on as well. But yeah, if you can actually source that somewhere, then you can potentially have your controller board running at 2 voltages, because you can potentially source both 24 and 48 or even 60 volts from USB PD. That would be intense and amazing. And at the same time, you could use a standard USB PD cable to supply your toolhead with energy without needing an adapter board, without needing anything. So essentially, one of the problems we have right now is that people need to deal with mains wiring. People need to deal with mains power. But even your heated bed may be potentially yeah, supplyable by using USB PD. I mean, it's 4 amps, 60 volts, right? It's still, I mean, it's half of what we currently have. so the bed wouldn't heat up quite as fast, but once it's heated up, I mean, how much power do you supply to your bed once it's heated up? Anyways, moving on here, we are asked to insert these, and we're asked to insert the A in the A. So this is actually B. This is also B. Way to go, me, for sorting things earlier. Let's put the letter to the outside actually, so we can still read it. And yeah, we identified the correct drive mount. And then we're into bearing stacks, I guess. Bearing stacks go in these. Now we need to find out whether we have the correct Oh, this is a fail. I mean, it would be really nice, and I'm pretty sure you can't actually do this wrong once you assembled it, but it would actually be really nice if this letter here. I'm not sure if you can see that. Let me see if I can show you this on the top cam. Wow, that's also somewhat too bright. Suffice it to say, there is a letter A on there, and there is a letter A in here as well. And the way we put this together is like you need it to put it together is like this, right? The thing I find interesting here is that both hides the letter A on the moving part for the motor, as well as on the mount. So why not put the A on this side instead? That way you are still able to see which mount it's supposed to be. That would be nice. And then obviously this goes on top. I'm guessing we are dealing with this for now. We already have the heat set insert in here. And I think we can move on to the screws. So let's take that off again, and let's see what we need to screw in here. M3 by 35s. Those should be reasonably easy to find. Let's see here. Yeah, but that's M3 by 30s. M3 by 35s, awesome. So we found them. We need two. Those two go in from the top. They go into the hole here and here. Now we're running into a bit of a lip here, so we'll need to just push those through. Maybe a bit harder. Maybe we can actually use one of our insanely nice screwdrivers. That's too big. Should be this one. Yeah, that elephant's foot obviously isn't just outside the part, it is also going to be in every single screw hole, so better to print with a bit less, but if you have the choice. Anyways, back to the Nitehawk. I really like that some vendors are now using USB, and especially for beginners, having a USB device is a bit easier than having a CAN device. In the long run, I think CAN is the better choice though, because it is way easier. Whenever you want to, let's say you have a Toolhead, you're running USB there, and you want to connect additional devices to it. With CAN, you can just like connect additional devices direct to the two wires, and you're done. With USB, you need another USB controller, like a hub controller, and that kind of makes things harder. So yeah, I don't know if that's ideal. Also, USB is a packet-based format. Well, CAN is as well, but in USB you don't have as much of a choice in terms of priorities, in terms of how you deal with those priorities. And you have way bigger packets. CAN is meant to be more real-time, while USB is meant to be more universal. And this real-time component of CAN makes it more reliable with multiple devices attached, which I think may be relevant in case of 3D printers. I'm thinking of cases, especially when you also have a webcam attached. You only have a single USB controller or two. I am guessing that there may still be some reliability ability to be had, apart from the flexibility of just being able to connect whatever to your already existing CAN bus, for example on Toolhead or on your ESF or ERC5 if you will. So I think LDO left quite a bit of innovation on the table here, which I find kind of sad, because USB PD could potentially even allow for simpler builds, and that would potentially allow even more or even less electrically skilled, even more electrically scared people to join the hobby. Yeah, until we actually see a good implementation of USB PD, I will therefore be sticking to CAN. I like the bus system. I have not had any problems with it yet, and I think the concept of CAN and how it works is pretty cool. The flexibility is pretty cool. By the way, if you hear something woofling around behind me, that is Enek. He's currently dreaming. Yeah. Yeah, so that's the story with the Nitehawk. My favorite toolhead board at the moment, by the way, being the Mellow Fly SHT 36, I think. Mainly because it has a really good XT30+2 plug. And I think that should become the standard. That's another thing that I don't much like on the Nitehawk as far as I've seen. I think it uses the same plug. And I can totally get why. I can totally understand why they would do that, because it is a really, really practical plug, but there may be some care to be taken to not mix those up now. So I hope we see something innovative there over time. Yeah. By the way, we're currently doing Baering Stacks. Oh, and I see that we did one of those Baering Stacks wrong. because we're supposed to first find the we're just gonna make it work here. We can take this off and to this side, and then we can put this on. Baering stacks with Vorons, always washer, bearing, washer. In this case, it's even a larger shim than your washer, bearing, washer. Although I'm kind of questioning where that part's gonna be. Let's see here. Because I haven't seen that yet. These are for the Toolhead. Let's see our other. Oh, that's supposed to be a printed spacer. And it is supposed to be in yellow. That might be an issue. We may have a problem there because I don't remember printing that. I really don't remember printing that. And it says we should have 6 of those. That's interesting. Let's check the kit very quick. Let's make sure that we don't have a replacement part, because I can see a case where Fysetc would potentially supply us with one. But it is supposed to be 6, so one. Interesting. I guess the Trident will need to show its prowess again to get this done. Why, oh why? Alright, no matter. We can still prepare a couple other things and then move on to the Toolhead already. That's probably a good plan. But first, let's move to the slicer and make sure that we get Orca selected here so you can see what's going on. There we go. That looks better. That looks way better. And let's turn on the Trident so it can do what it needs to do. And no, this was not my lights flickering when I turned on the Trident. This was actually HomeKit being stupid. In a sense that I have a device that is currently not connected to my HomeKit setup. And that device, for some reason, well, we know that that's gonna fail whenever HomeKit tries to control it. But HomeKit decides that if I do change a scene, it needs to change all the scene or it will revert it. And it will do so once but not twice. So it sometimes doesn't do it, but sometimes it decides, hey, you tried to reactivate this scene. Let me turn that off for you again. And it is annoying the hell out of me. The Trident, by the way, being up already. I did, however, not charge the filters on it, so that's going to be interesting. Also, we are asked to do this with our accent color. Let's move the camera down here. Now let's see here. Yeah, I think I want to do this with the accent color, which means that we should just preheat this to 250, so we can take out our current filament, which is the primary. We're also already going to preheat the bed so we can get this started earlier. Yeah, by the way, let me know if I'm completely on the wrong track, if I should give that Nitehawk Toolhead board a chance. Because I think LDO has some work to do there. I would really appreciate it if they did. I think it's not worth switching to a USB toolhead that does not use USB PD. But yeah, your opinion may differ, and I'm very much looking forward to hearing it. Put it in the comments, and while you're down there, share, like, subscribe. And check out the Twitter and the Discord. That would be awesome. I'd really like to see you there. Alright, let's open our filament box here to pull out our filament. Make sure that we extrude twice or retract twice. That should be enough. By the way, this toolhead does have a sensor on it, and we can actually see when the filament left the extruder, so that's just for safety. Click that another 2 times, and that should now allow us to just pull that out, roll that up quickly, and put in another filament. The other filament, by the way, being the yellow, which is ASI, which I do not like to print, to be honest. Need some light to untangle this spool real quick, otherwise I will forget. And when you forget to untangle your spool, that usually means trouble. sorry, getting sidetracked a bit here. Just making sure that this did not slip out of my hand and cause a knot here. I think we're good. I think we're good. Otherwise, yeah, come back next time. See what happens if we print with it. Might be carnage as promised. It might be carnage as promised. Oh, and let me know if I should go into more detail about CAN and how it works. I have some decent experience with it. The Trident's also running on CAN. The ERCFs are running on CAN. So even in 3D printing world. Besides it being really easy now compared to I think what it was a couple of years ago. Yeah, let me know if that's in any way interesting to you. All right, so we're loading our filament. Should arrive at the toolhead soon. No, I don't have the ERCF connected currently. Reason being, because I'm an idiot and I dropped it, and that makes it need a rebuild. So if you look at your screen right now, you can probably see it sitting in the background. That is the ERCF for the Trident. That needs to be rebuilt, reassembled, retuned. Something we're gonna do on this channel. All right, I think we have contact. Let's extrude here. Maybe not. Let's try that again. Yeah, there we go. And it is already yellow. By the way, this is I think a result of using Diamondback nozzles. If you check out the webcam, yeah, you can't actually see a lot here. And by the way, I still haven't fixed the frame rate on that, but it is already bright yellow. And I think one reason for that is because the Diamondback nozzles, when you do multi-filament printing, result in less contamination of your individual colors. I'm not sure how much difference it makes, but I did notice that I somehow needed less purge filament than with a standard brass nozzle. Again, I could just be completely wrong here, but I figure that your old filament will not, at least not stick to the diamond surface on the nozzle itself as well. It'll still stick to the brass inside. So yeah, and we need the STLs. We're asked to print a spacer, so the question would be, where is the spacer? Spacer, spacer, spacer. Toolhead tools, toolhead. Skirt paneling, multi-body STLs. Display cooling skirt, nope. And it must have an A in front of it, I guess, because it's an accent piece. Yeah, that's the one. We're going to use yellow, so let's make it yellow. And then let's multiply that. No, we're gonna use yellow, I said. And then go Command M for multiply and get another 5. I will quickly check the other box if we do still have the spacers, because I want to make sure that, of course, we don't waste any filament here. But I can totally see myself not printing those, thinking those would be the Toolhead spacers. And those Toolhead spacers actually properly suck. I would suggest definitely not using those if you have any chance at all. Cool, this looks good. Let's just slice the plate. I am going to increase the minimum layer time here though. Oh no, actually we don't need to. It's 6 pieces, so we should be good. Let's slice that. And it's supposed to be 9 minutes. Let's see what we can do here. I guess we're preparing the other side in the meantime. The things that happen. The things that happen during a build. Let's move back to the manual here. And we're in the meantime going to look at our motor assembly. Put those screws in here. And same thing here. We still have to get by that lip. So there we go. And using the electric screwdriver here will wear away the lip just as much as it screws through it, so should be reasonably fast. We just need to be sure that we use the correct ones. Oh, that is, by the way, a good point. So it's going to be this one. We still have 2 bearings, 2 washers here. We need another 6, 4, 5, 6. And we need another 6 washers, I guess. Where did I put those again? Those are the big ones. I need these small shims. Oh. Gotta look properly to see them. And by the way, I'm not sure if this is correct, but I always try to orient the side without the burr or without the lip to the bearing. I have no idea if that's the way to go, if that's the way to do it, but it has worked for me so far. Let me know in the comments if that's the right way to go. We're now adding another washer, and then we're going to go washer, and this is the inside, so we only need one washer there. Now we're going to be adding a washer, 2 bearings, damn it, pull this through again, 2 bearings, another washer, and 2 more. Washer, 2 bearings, bearing 1, bearing 2. Wait, why do we have an additional washer here? Yeah, because we pulled off one of them. So let's put that there. Put that bearing on top and the washer. And this should be the stack for our B motor. Let's also already add the B motor block to the underside. Gonna lightly screw that in here. Might already give it a bit of additional resistance to falling out, and this is B. Okay, so this is B, which means I'm going to put that with the B assembly. So this is A, we're going to put that with the A assembly. The interesting thing is that we can't conclude the A assembly because we need the spacer first. The B assembly we could already add the additional bearing because the spacer goes on top. Next thing we can do while the Trident is still warming up, so let's quickly check on it. Oh, and the device has not gotten our command yet. Go, please print that. Check the console real quick. Let's do it this way. Let's restart the firmware. Oh, my dear Trident, please do not break my heart. It would be a very, very bad, I was gonna say, would be a very, very bad time to shut down. But it is doing it. Let's just start that job from here. Let's see what happens. Bed's preheating, so this looks fine. I'll have to check what the integration issue with the Orca Slicer is now. But I will do that after the stream, because we're here to build a printer. We are definitely here to build a printer and not muck around with Orca Slicer. Yeah, we build our AV assembly. What else can we do here while this is still printing? Yeah, I guess we can get started on our toolhead a bit. And let me pull that off. Oh no, we can actually do our motors. That's a good point. Our beefy, nice little motors. Let me show you the manual here real quick. So we're asked to add the A and B motor pulleys, which means that we will need some Loctite, in this case some real Loctite, and we will need the pulleys themselves, which are here, and the flange on the pulleys is meant to be 17.5 millimeters up from the surface of the motor, which means that we will need to use our calipers to get this as close to what it says there as possible. And let's go to let's maybe do this in millimeters. Yeah, 17.51 should be fine, I'm guessing. We can try to get the 17.50. There we go. 17.50. That's the difference or the distance that that one pulley needs to have. And let's grab ourselves a pulley. First thing we're going to do with these pulleys is we are going to take out the set screws. Because these need Loctite. Once they have Loctite, they can go back in. And I think the Trident finally woke up and did its thing. So it should only be 9 more minutes to us actually having some proper spacers while we're repairing our pulleys here. If you remember last time, I told you that this is actually easier to do on screws when you can directly apply it. Not so much if you can't see it. Oh, come on. And don't cross thread these. I mean, probably a way to get them not to come out again, but you may want them to. Oh, and you should definitely, if you want to screw something in, you should switch it to a mode where you can actually screw something in. That might help. Not sure about that, but it might. And another bit of thread locker. Let's actually apply this to the side and not the underside of the screw. And you can actually wick some away with the nose there. There we go. Now let's get this on the motor. This being a D shaft, so you want to align one of these set screws with a screw with the D, and one is then going to grab something else. But if you can get one of the screws oriented in a way that it sits on the flat side, that should give it a lot of additional stability. And we're going to back that out just a bit. I actually don't like that because it is still moving around way too much. We want to be able to move it up and down, but we don't want to be able to move it side to side anymore without actuating the motor. And then we can use our calipers. The way I would use them here is again by using the bottom side. Use it vertically. Don't let it also be influenced by gravity. Then just push the pulley against the underside of the calipers. And pull that tight. Noticing here that it moved somewhat, so can loosen that somewhat. Underside, then that's actually not loose enough. That should be fine. So that is the B drive motor. You can now also tighten the other one, the other screw. B drive. A drive, we can look up what the distance needs to be there. And the flange is actually supposed to sit 8.5 millimeters from the bottom, which means that we need to set it to 8.5. There we go, 8.5. Same as with the other one. Gonna take out the set screws, Loctite them and or thread lock them and put them back in. Trying to do this a bit more careful this time. Whoa, and that is definitely cross-threaded. There we go. By the way, don't ask me how I like this electric screwdriver yet. I haven't decided. These long tips are actually not stock. They sometimes make it more easy to use, sometimes more difficult. It's I don't know. The screwdriver itself has a mode where if you, or it's always on that mode. If you have, if you push down on it, it will start screwing things in as well. Not sure what I like about, how I like that as well. So A motor, we want to do in this direction. Let's find the D. Let's do that there. Screw that down a bit. There we go. So we can barely move it. And then use our calipers again. Push that a bit to hold it in place. Screw it down. Loctite in there. Cool. Didn't forget the Loctite. Very important. I tend to do that and then I need to take things apart again. There's not too many other things we can use Loctite here, on here. But let me quickly check on the Trident. That thing is an absolute beast. It just does it. It just does it. Let me give you a quick look at it. It's not a good look because I still haven't fixed the camera on it. But yeah, there you go. That's what the Trident looks like. That is what it's supposed to do. And quality seems really good. So what I was concerned with the layer time is cooking that off usually has a few implications. And by the way, I do need to quickly turn on the filters here. And I do actually want to open a window. Give me a sec. Oh. Yeah, I guess this stream is not going to be too long, because it is freaking beautiful and clear outside, which means I need to take the telescope and have a look. Have a look at the stars. But let's first make sure that we get to the electronics part. So our Trident is finishing up our parts. We, in the meantime, assembled our motors. Since the Trident's still not finished, and since we want to leave it cooling down at least a bit, so those parts stay strong, I'm still tempted to start on the toolhead. Let's do it. We can put it aside as soon as we get to a point here. Well, actually, no, for all of this we need to follow the steps properly. And we're not going to do the filament sensor. Not going to mount the Zee Motor yet. I think the most disconnected part that we still can do is the tool head. So we should get that started. And that being the other side, so here we go. We already did the heat set inserts. We made sure that these are ideally oriented as they're supposed to be. First thing we need to do is get that 2x6 in this case. We're looking for a flathead, and only one of a few, so it must be a really small package then. Let's see if we can find it. M3x8 FCHS M2.5 M2x6. Awesome. And since this is going to be really freaking small, we need our snapmaker screwdriver. That's barely big enough, and we need the cat ears. We're going to screw the FHCS screw here. Yeah, so we threaded it all the way in. You can see it here. There you go. That's our little flathead. Since we're screwing into plastic, we stopped as soon as we hit the, as soon as we touch the plastic, otherwise we're gonna strip it. Obviously don't want to do that. Let's pull up the manual again. Otherwise, the prep we already did for our beautiful yellow tool head. So we're now asked to assemble the clamp here, the clamping mechanism. And as far as I remember, yes, I printed that in very, very nice teal. That part needs a slight bit of cleanup. Yeah, by the way, there's good deburring tools out there. There's tools out there that are not as good, not as high quality, I'd say. It doesn't matter what you get. I very much subscribe to the Adam Savage theory of buying tools. So get a cheap tool first. 80–90% of your cheap tools will last your whole life. And if a tool actually breaks on you, replace it with a better quality one, if you deem it necessary. Because then you have really good quality tools where it actually matters, that you actually use a lot. And when your tool breaks, you will also have found its limits, so you will have more information on what you actually need in a tool. Because when you get a tool first, you usually tend to not know what exactly you need to expect from it. Crimping pliers or anything else, right? Many people swear by those PA09s. I have a reasonably cheap set that costs half as much, and I've crimped so many connectors now with it. I don't see that failing anytime soon. So while I may not have the best crimping quality, since I'm not doing this professionally and I don't need those crimps to always be completely perfect, although some OCD might apply and I may or may not have crimped a couple of things more than once just to make them more perfect. In general, doesn't apply. Okay, so we're also being asked to lubricate our gear here, and this, by the way, being the gear that doesn't have a set screw. So if we look at our baggie here, we see there's multiple gears in there. We want to use the one that doesn't have a set screw because that goes onto the completely round shaft that we're going to insert in the clamp, and put that over there. We still need to find the other bearing. The one with the set screw is meant to go on the big gear, so make sure you don't mix those up. Might not end well. The assembly itself looks something like this. Right, the gear running there. but we're also asked to loop that, and to loop that, in this case we're not using an EP2 grease, we're using Super Loop because it is lighter. And obviously I didn't realize that this has no nozzle. So how the hell? We're just gonna grab ourselves another syringe. Now I need to find the syringes and push a bit of Super Loop in the syringe, then use the syringe to push it out. And give me a second here, because I really don't have any idea of where that syringe kit is. Also something to get if you want to build things. Syringes can be damn useful. Oh well. I'm not gonna deal with this right now. We're just gonna wing it. There you go, winging it. What we can do here is just take our shaft, get just a slight bit of grease on there. Rub that in with our fingers. So now we have that greased already, and obviously we also have grease on our fingers. Gonna take one of these just to put that down without, ideally without greasing our work surface. Then push our bearings back out of the gear. And grease those by running that. Also put a bit more grease on our finger here. By the way, if we're working with grease, try to wear gloves. I know I am not, and I am very sorry I am being a bad example here. But grease usually is oil-based, and oil-based things tend to have some kind of negative effect on your body. Right? People tend to talk about carcinogens. I'm not an expert. I don't know how dangerous this is even going to be for an individual that, like me, just touched not even a milligram of grease. And usually when I'm working in bikes, I actually wear gloves and have grease presses and grease ports, so I don't actually come in contact with that. But in this case, I don't think it's an issue. Now we need to look out for the orientation. We want the thing up, and we want to have the teeth on the right side. Press that in, and that runs beautifully. Let me get you back on the manual. And we're now asked to check our big gear. The big gear needs to have a minimum distance from the one end of the shaft of 3 millimeters. So what we can actually do is just, I can actually show you this on the overhead. Take our calipers put that on there. And I guess we have a problem. Because this is, well, actually, let's do it here. Check the short end of the shaft. If it is longer than 3 millimeters shorted to under, the design will have a printed jig that can be used to help sand down the shaft. Alright, I don't think we need to do this because ours is only 2.2 millimeters. I guess we're good then. Nice. We are also asked to see if the bearings fit. So I guess we will need our baggie again that had those in. Oh, let me move you to this overhead first. Our baggie is obviously not as easily identifiable now, but still there. We need to check if our bearings fit. Here we go. Let's see. That sits very loosely on there. That sits very loosely on there, like that. It's strong enough to hold it in place, but loose enough so you can actually take put it on, take it off. Yeah, so we don't need to sand anything. It fits. Nice. Let's find the part that one of the bearings goes in. So this is the plate. We can already put this bearing in here. And obviously we want to press on the outer ring if we're pressing in a bearing, not on the inner. Because if you press on the inner ring too much, you might actually pop it out. The manual also asks us to put in a 3mm hex nut that we actually have 150 of. Oh, there you go. So let's do it. There. This is actually not pressed in all that much. It's still going to move. By the way, if you're wondering why I am printing this in the primary color while the toolhead itself was in an accent color, I actually decided I wanted it this way around. Mainly because I think having the teal printer and then a yellow toolhead zipping about this is a better design. If we ever get to multicolor printing, that teal, that yellow toolhead will then get a teal logo in it. That's gonna look so good. That's gonna look so good. Back to the manual. So we're asked to also put in the bearing in here. I tempted to press that down. The question is with what? Because again, we want to press on the outside ring, not on the inside, and we'd need some kind of a tool for that. Yeah. By the way, again, just a reminder, let me know how you like the stream setup. I am still toying around a bit with the setup in general. You can already see the GoPro has somehow disconnected again, so I'm really not a big fan of that. I'm actually pretty disappointed. We will need to exchange that somehow. This is really rather disappointing, to be honest, because yeah, I would expect a GoPro to do better. But yeah, I guess these cameras are meant to be, well, it's hard to say, but they probably don't work well with any kind of stationary mounting. So yeah, kind of disappointing, but I do understand where that might be coming from. Still, GoPro was the go-to for action cams. When I'm going snowboarding, I do have better results nowadays with using a different camera from DJI. So food for thought if you're looking for an action cam. Maybe look at the DJI stuff first. I don't like my options for pressing in things right now. Let me think here. Oh, that might actually work. We could use the biggest one here. I still don't like that we're pressing mainly on the outside, on the inside. But at least now we're getting somewhere. Yeah, that's good. That's fine. That's how it's supposed to be. And our bearing is in. There you go. And we can actually use our gear here to check if it's straight. I guess that's pretty decent. I mean, we can still wiggle it and move it around somewhat. It's workable. It's workable. All right. What else? We're asked to put in our other part for the clamping mechanism. Again, this needs a bit of a cleanup, so very quickly going over this. Get one of these, really get one of these. I don't have one in the description, I think, but I can add one. Even a cheap one, as long as it has exchangeable tips, you should be pretty much set for life for anything with plastic. I can see why you may need some higher quality ones if you're doing metal deburring a lot, but this is plastic. This is just to yeah, be a bit nicer on your hands. Also, I am quickly going to go over this because that burr is also somewhat ugly. clean is so much nicer. It's gonna look so much nicer as well, because that way we don't have that burr sticking out from the tool head. Push comes to shove, it's going to like protrude a slight bit, give us a bit of a an indentation, but in general it's gonna be fine. What we also need to do here, and that's, by the way, it's good that Fysetc gave us a third bearing, is we need to add the filament sensor here. And I completely forgot that we need to do that. So it's too bad that that doesn't come stock with this build, but I guess that would be a bit too much hassle. We're going to first insert this here. Oh, I'm deburring stream. This is the deburring stream. Removing the elephant's foot. That poor elephant. And again, quick reminder, join the stream. Next time you're watching, join. Let's have a bit of a fun discussion. If you're not comfortable with the times I've chosen, I don't have too much flexibility in that, because obviously I am working, and I'm working for a startup, so, or with a startup actually, so most of my time goes in that, and that's actually the way it's supposed to be. This is what I do for fun, to relax a bit. So that's kind of how my time management works out usually. But I am still open for suggestions, and maybe there is a compromise to be had here. Please let me know if this collides with anything you're doing with any other streamers. I have literally no idea. The only ones I know are streaming are Nero and Steve, but I'm not sure if any bigger streamers are still on currently. So I don't know. Let's see. That is in there. It's deburred. We have our bearing in. We can now insert our clamp here. This then, and going to connect that already, to be honest, so it doesn't fly around as much. Gonna already screw in the thumb screw here. We are also, this is again special to this build. Let me put you in the overhead here and show you this close up. We have this cavity here, and we have a bearing here, and we are going to insert the bearing somehow. Let me use some tweezers here. Where did I put the tweezers? The tweezers. Tweet, 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 tweezers. By the way, those self-locking tweezers, godsend if you want to do something that requires coordination on multiple levels. I am not liking that position though, because I think it needs to go in deeper. And I think we have another piece of filament to remove there, which means we're going to use using our tweezers to make sure that that path is completely clear. Yeah, you can see it there. Because obviously that bearing needs to move freely, because it will get pushed back by the filament. Against our switch that we're going to install there. Yeah, that's better. That should do. Now we do have a problem here, of course, because I don't have a switch wired up. And in this case, that's absolutely necessary because we want to close that tool head. So question is, do we continue AB motors or do we continue on this? I am kind of opting for this because we need to get through it anyways, and having that at least closed reduces the amount of parts we have significantly. The problem my scatterbrain has right now is I need to remember where I put the frickin' switches. Oh, look at that, switches, nice. We are going to need some pliers here. Because, and let me put you on this, we want to take off this actuating lever. It's usually pretty easy to do. Don't need that. And if we now just put in our switch, this is how it's supposed to sit. You can see the bearing there and the switch, and we'll go to wire it up in a second. But what we're first going to do is we're going to grab ourselves a piece of filament from somewhere where we previously had filament in hand. And oh, it is so good that ABS doesn't break easily. Otherwise this would have been already over. They could have already shown you. Yeah, by the way, if you're interested in recycling, we already touched on that. I actually looked it up. The people from Filament are showing how CDs, for example, get recycled, and how their tech, although probably way too expensive for anyone, can allow you to recycle your potentially substantial anime collection that you ripped from Netflix CDs you ordered about a decade back, and will allow you to then recycle those. Let me take out the headphones here. And I will need to hold this in position here. This does not seem to be working yet. That is somewhat disappointing. We maybe push this in even further, because obviously we want the bearing actuated by the filament, and if there's anything in the way, so let's push that all the way in. And the bearing can actually make contact. You can see that on my thumb there. So that's good. But there seems to be some friction. The switch works. But the bearing isn't sliding smoothly. Let's see what we can do about that. May need to clean that up somewhat. Still, by the way, we can actually gently zoom you in a bit. I will use the tooling knife here, because I think it's the better tool to do this, to clean that up, than relying on the sharp edges of the tweezers to doing this. But there seems to still be something blocking our bearing. So yeah, that's something we should always make sure works well. Because if you don't test this part, and I actually see where that's probably failing. If you don't test this part well, you'll have to disassemble the whole tool head. And I'm guessing you have different plans for what you want to do with this printer. So yeah, just do that thoroughly. A bit of mucking around in there. Again, some tweezers. Put that back in. This what they... And we want this to move as smoothly as possible, so it can actually actuate the switch, and the pressure from the spring can move it back into position. So let's put that switch back in. And now you can probably hear that. That is how it's supposed to be. Nice. Clean that up. I guess we need to wire a switch now. And we're so far from what the manual told us to do next. Let me get rid of these plastic flakes here. Filament flakes. So we don't contaminate any of our surfaces. Oh, and someone's awake. Someone is awake and got up from his sleep. Hello, Enek. Hey, Enek. Hi. Look at that. That is one interested dog. Hey, Enek. Dingetun? I just asked him if he wants to do something. Was kannst du? Was kannst du? And look at that. I can just ask him if he can do anything. Was kannst du noch? Yeah, fine. Was kannst du noch? Oh. And just by asking him, he's just gonna show me what camera work. Every single trick. Tits. Tits. Platz. Steh. Fine. Bank. 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 Oh, he's showing us that he knows what a seating opportunity is by laying his head on it. I guess, well, that's actually part of the blind dog training. Drauf. Drauf. Fine. Look at him. He's so cute. Hey, Enek. You can even ask him if he's a border collie. Bist du ein border collie? Bist du ein border collie? Ah, I guess not today. Bist du ein Spitz? Oh, no, he's not a Spitz. Bist du ein border collie? Enek, bist du ein border collie? Oh, I guess he's not interested in telling us what he is today. Kannst du tanzen? Komm. Hier. Nein. Kannst du tanzen? Yeah, but he's always happy to dance for us. Fine. Platz. Fine. Steh. Steh. Platz. Fine. Männchen. Fine. And let me give him a treat for all his hard work. Because obviously he earned that. And he knows it. He knows it. Ooh, ooh, ooh. He definitely knows it. Yeah, there you go. Some Enek interlude. I tell you, best dog in the world. No offense to Daniel from Modbot. I'm pretty sure his dogs are really good as well. Because there is just no bad dogs. It's always the people keeping them. It is always the people keeping them. Alright, so what we're going to do now is we need to solder something. So we're going to need to quickly set up the soldering station. We're obviously not going to use the Hotend. We are going to use the JBC. I don't know the product number or anything offhand, so you'll have to check the description. And if you're there, leave me a like, subscribe, do the YouTube things, write me in the comments. And if you go and buy anything from that list, please make sure that you actually need it, because for building 3D printers you may not actually need a premium soldering iron like the JBC. The advantage that the JBC gives you compared to other irons, even that weird little TS100 that is probably enough if you're just building 3D printers, but the TS100 definitely doesn't have the thermal mass as the JBC has. So if you're working on actual electronics, the advantage is usually that the result is usually that your tip does not cool down as much if you or once you hit the surface of something, which means that the temperature is much more stable, which will result in your tin to flowing better, and that obviously leads to higher quality or even a faster soldering experience. But if you're doing 10 solder joints a week or a month, who the hell cares? So always remember, while I do appreciate anything you do, from tipping to using the affiliate links in the comments, don't just do it for me, do it for you. If you learned something here, just tip us. Don't necessarily buy stuff you don't need. And yeah, that would be much appreciated, because while I did have some of this streaming set up, some of it is also very much bought to just make this stream happen. And just to give you a bit of a number, with the 2 extra stream links or cam links and the by the way, cable stripper, I find them useful. Not sure if you need one. Yeah, we only need to do one end for now. That the other one stays consistent. Anyways, I actually bought an additional VH5 for 400 bucks for this stream, and the second EM5 Mark III. So yeah, that's a 600 buck investment, plus the cam links for 400 bucks. It's not cheap to bring this to you. It's not cheap, and anything to help offset the cost of kit and tools then is obviously very much appreciated. I'm going to use mostly the tools I already have here, but in some cases some additional investments have been and may in the future be required. So if you can help, that's much appreciated. This, by the way, being a PC Byte kit. I usually only use that for measuring things, because I have some really nice probe attachments, but in this case we can actually use it to solder our switch here. Let's get that in there. There we go. And the question is, how are these wired? You usually have the ground to the switch, I think. We can check that real quick. Or I can check that real quick with the handy dandy magnification, just to see what the orientation is. Yeah, so the ground, if you have a switch like that in hand, you usually have a normally closed and normally open input, or yeah, C and NC, and you can reasonably well rely on the common connection or ground connection to be on the be below the switch. Let's now line these up here. Oh, and what we also want to do in this case is we want to grab some heat shrink to make sure we heat shrink and de-stress that connection a bit, just to make it a bit nicer. We're not gonna overdo it. We're gonna use some blue heat shrink, and we're gonna split that in two with the El Cheapo pliers. This is just meant to cover, well, actually that is too short, but it's meant to just cover the, actually in this case it should actually be that short because we don't have a lot of space. So let's keep it this short. Let's see what happens. Need to obviously put that on first. Yeah, I think that's more than long enough. Yeah, that's actually perfect. Let's give it a bit more room here, and we can actually clamp that down with the cable, so it doesn't accidentally move into the area where we're soldering. Now we want to line these up a bit with the contacts we're trying to solder, and move those below so they press against them a bit. The reason why we want them to press against the contacts is because if we can get them to, they will actually, the part on the cable will actually heat up with the part on the switch, which is what we want, because we don't want to have a big temperature differential between those. Otherwise the solder will adhere well on the one piece, which is our switch, but not at all on the other. I would so love to show you this on the overhead, but I'm not sure this is going to work out. Let me see here. Let's increase the chaos. Let us increase the chaos. Let's see if we can get enough stuff out of the way so I can actually show you what's going to happen here. Oh yeah, that's going to work. That's my mouse. There we go. Here we are. And that way I can actually also see what's going on, even though it's quite far away from me. And as you know, I am not actually seeing all that much. So yeah, keep that in mind if you ever say to yourself you can't do this. I have a pretty bad eyesight actually, and just because of me using the correct tools, using magnification when I need it, not being shy about it, finding tools that help me as much as I can actually still achieve these things. So it's not a matter of how you're physically built. Well, it may play some role, but it's not the deciding factor. It's much more, do you want to? And if you... Oh, that is shaky. If you want to do it, you likely can. There you go. Important, obviously, is that you heat this up before applying the solder. You want the part as much on temperature as possible before applying the solder, so the solder actually flows well around it. And this is, by the way, where a good soldering iron helps you. Is oh, and I'm not sure that's a good solder joint. No, that wasn't. Good solder joint actually helps you to get much more even flow. That's fine. That's good as well. Now we need to get the heat shrink on there. And for that we are going to also need to, by the way, we can turn this off and put it away now. We don't need the soldering iron anymore. But on the flip side, we will need to actually let this cool down a bit, which shouldn't take all that long. But we will also need our hot air station, because I am definitely not a fan of using a lighter to doing this, which means that we're going to soon run out of space on this frickin' desk, which is obviously the only space we have. I'll need to figure something out. Actually, I need to figure something out right now, because with the streaming setup, I can actually not reach the power plug. So this is likely going to be a don't do this at home kids moment, because now we have our power for the hot air station hanging, which you luckily cannot see. I am very thankful for that. What I do see right now, though, that's actually bugging the hell out of me, the fact that my camera is crooked. That sucks. Let me see here. Maybe we can do something about that. Haha. There you go. Well, almost. Can still fix it a bit more. There we go. You do not need to see what Corona did to my waist. Anyway, that seems to be on temperature. It's stating 201. Actually, we want it at, yeah, 201 is fine. Heat shrink, we don't want to melt anything else. And then let's give you some heat shrink ASMR. Let's see if we can. You want to move, you don't want to melt it, you just want to shrink it. And yes, I realize there is a cable from the soldering iron in the way. I am sorry about that, but that tip's still warm. So there isn't actually much I can do about that. How do you know how if your heat shrink is all the way shrunk? Most heat shrink has some kind of adhesive inside, and if you see that bubbling out at the end, it's usually cooked. Might be harder to see on these, and I think we're already done. But that's generally how you judge your heat shrink. Yeah, that's good. That's pretty decent. So, nice long piece of wire. Now let me get this under the table and hopefully in a position where I don't just kick it somewhere against the wood so it causes a fire. That should be fine, I guess. Let's not burn down the house just yet. Still a couple of things we need to have fun with. All right, so we have our wires on our switch. We now need to put them in here. And this specific variant of the cowling has a hole here to feed the wire through. So we can just do that. Obviously, because of the heat shrink, we need to press in a few things now because it's going to be a bit tighter. But that's also why we added the heat shrink in the first place, is because things are so tight in there that we can't actually be 100% sure that wires don't touch. And if we get those wires isolated to the actual pin, that's going to ensure way better that nothing's touching. That still works. We got our wires. I actually chose yellow here for the signal wire. So the thing that's left now is to find some, I'm not sure, I think last time I checked I used some 2x8s. I would 10s. I would actually like to have some by 8s instead. And they need to be self-tapping. M2x6s we have a bunch still. M2x6 flats we also have. The problem is if we use M2x10s, which are these and which the M2x10 self-tapping, we may need to cut down one. Actually, probably gonna do that right now. Because otherwise this is going to be far too long and it will stick out the other side and will interfere with our gear. So that is shortened. Now I have a dangerous little piece of metal floating around somewhere here that I just lost track of. But I guess it's all good. I guess it's all good. We need ourselves a Phillips screwdriver, and then we need to push in the shorter screw here in the lower hole, and we actually need to make sure that that really screws in well, because otherwise it will interfere with us mounting this, and the upper screw then in the upper part. It's a bit how you're doing. It's not as pretty as I would have liked to have it. But yeah, at least we have a filament sensor in here now. And I think it's reasonably well in there. Still working. Nice. Filament sensor in the toolhead for... by the way, in case you don't know why we're doing this, because it's kind of a weird one. It's because of frickin' ERCF and it working better. It doesn't mean that it doesn't work without one, but it works better if you have an actual filament sensor in the toolhead. It's just the way it is. Yeah. Doesn't mean you have to go through the trouble, but here you go. Putting together our front, putting on the cowling. Let's see if this actually fits well. Yeah, the screw still can go in a bit deeper, to be honest. It leaves a bit of an edge still. Which may mean that we need to push down the switch a bit more. Without actually cracking it, because that would suck so much right now since we went through all the trouble of preparing it. And push comes to shove, we can still grind it down, but I really don't want to. what we can also do, because this screw actually has a hard time biting, is we can use a non-shortened one to thread it in first, and then use the shortened one to actually fasten the thing. That may give us a bit more purchase. And yes, this is electric, so what the hell am I doing here? Where did I put the screws? Where did I put the screws? Where are my self-tappers? Here. And yeah, things are kind of tight. And this, by the way, is a mod, not an official Voron design. So quality on it may be less than you expect from a Voron endorsed printer with manual and everything. It does work though. It does work. I think it seems really good. I tried it on another project. There we go. See if that fits better. Still not perfect. Still not perfect. That is kind of driving me nuts right now. Let's see if we can get a bit more control with the via instead of the El Cheapo. Again, we need to be careful here that while we do want this in there securely and as far as we can, we don't want to crush the switch, and the switch is now sitting in there very securely, very well. But the screw is not getting as much purchase as I would want. I guess we're going to leave it like that for now. So yeah, cool. Got that in there. And then we need M3x25s to lock it down. Let's screw down that mid body to the cowling. Gonna first fix our setup here so I don't get confused on which tip is on which screwdriver. And then let's grab the Bosch here. The Bosch, by the way, doing quite fine. I don't have an issue with it yet. Especially the torque that you get, or the not torque or the torque that you don't get when screwing something in. They seem to have balanced it quite good. So you can actually do things that only require a light touch. Whoa! And my screws are escaping. Third one's going in here, I guess. Very light touch, very light touch. Obviously this one we do still want to get out a bit. Also, this one I just realized that our lever had a mind of its own, so we'll need to put that in. There we go. Obviously it's still too firm now, since it still got slightly torqued down. We'll need to back that off a bit. We may need to back that off a bit as well. And something is still too tight here. Let's loosen it up a bit. Let's give it some room. This is the biggest problem, by the way, with this mod, if you're considering doing it, is you need to be careful, because these cat ears, while they are cute as hell, like, look at this, right? This is so awesome, so cute, with the little nose here, and the eyes, and the ears. But the ears are somewhat sharp-edged, so just look out for those edges. And I just noticed that I am an idiot, because obviously when we add this screw, we also need to add a washer, which I think Fysetc actually supplied us with a nylon washer here. That's kind of cool. And then we need to take our washer combination and screw that back in. So we actually have a spring here that pushes against the arm for tightening. That is one hell of a hard spring. Don't remember it being that hard. Ah, got it. Yeah, there we go. Couple of actuations will actually fix any minor rough issues here. I am still tempted to back that off a bit, and back that off a bit. Because these 3 screws are actually not what is holding the mid-body in place. If I remember correctly, the thing that is actually holding the mid-body in place are 2 more screws, M3x10, from the bottom. M3x14. Interesting. Let's find the M3x10s. There we go. Now these go in from the bottom here, so there you can see them. By the way, that this should be fairly cold now, so I'm gonna put away the iron first before I show you anything else. And I just noticed that the music has stopped. Why has the music stopped? Let me check this real quick. Probably because it ran out of music. Ooh. Ooh. There we go. New music. Hope you enjoy it. There you go. Let's take off the soldering station. This, by the way, in my hands has already seen many tens to potentially hundreds of hours of use. It is still perfect. So if you're actually doing this semi-professionally, I would suggest getting one. If you're just doing this for fun, sometimes on and off, I still consider that kind of a waste of money. So yeah, make sure you account for your needs. Don't let anybody tell you differently. There is no use for you in giving a company more credit and more money than their products, or more trust than their products are actually worth. So make sure to always consider what the product is worth to you, what the service is worth to you. And don't let any company get away with shit. They need to serve your needs. Anyways, putting these screws here in. I am actually tempted to use a ball head. And that ball head is too small. By the way, one thing that really bugs me about this screwdriver, you can actually actuate it by just pushing it in. And by the way, that came in quite handy just now, but it still bugs me. It still bugs the hell out of me because it may actuate when you actually don't want it. All right. Fix that. So we got these two in the bottom. We got these three. These three don't necessarily need to be all that much tight, because otherwise actuating this will be a pain in the ass. Pain in the butt. Sorry, PG-15, PG-13. It's still quite rigid right now, so I will actually back it off somewhat. Still. Yeah, that was in there too tight. I would be tempted to put in thread locker here, to be honest. But since it's a mechanism, I would be also concerned to contaminating that mechanism and making it stick or sticky. So in this case, I actually left that off. Ooh. But yeah, there you go. That is our the start of our tool head. What we can also do still here is grab ourselves the remaining. Well, I will actually grab an ECAS for socket from somewhere else. And then we can put in an ECAS fitting. To firmly have our reverse button in place. Oh, that is not good. Oh well, should be fine. Should be fine. I'll push that in once we stabilize the tool head somewhat with the fans and stuff. Yeah, moving on. Let's see what's next. We're now supposed to assemble our gear with the remaining gear from the extruder package. The gear itself going to the front. There you go. And you can likely clearly see that there is a lock nut in there. And guess what we need to do now? Guess what? We obviously need to apply thread locker to that. Thread locker we got here, and these are so tiny. They are so tiny. Don't lose these. This little black thing at the very end of that screwdriver, that's what we're currently looking at. That's what we want to apply thread locker to. Damn, see that? Nice. And then we obviously want to screw that back in. That's gonna sit very, very well. We're gonna just slide that on here and make sure that the screw locks with the D profile. We're also going to leave about 3 millimeters, less than 3 millimeters on the front, and move back to the manual. Let's close the thread locker bottle, because having that stuff come in contact with our ABS parts would not be a good time. The manual asks us to check the orientation. I think we're good there. I wish it would also tell us the distance from the front, but I'm kind of guessing that follows next. No, it doesn't. That's weird. All right, so we're now supposed to insert this here. We'll need to obviously open this, and we will notice that the frickin' lever handle here has the part, the spacer for the ECAS fitting in the wrong spot. So we're likely going to hit our, what is this? That's interesting. There seems to be something going on here that we still need to figure out. I hope that's not gonna be anything major. But at the moment, the ECAS fitting seems to be blocking our handle, because our handle has its material removed in the wrong location. That may not be a good thing. That may not be a good thing. But we'll make it work. We'll make it work. Let me do something here. That should be an easy fix. Let's take that out real quick. And you can see right here that there was somebody thinking of that ECAS fitting, but it was quite clearly visible that that was in the wrong place. So what we're just gonna do is take off some adjacent material. And we are still hitting here. Yeah, that's much better. Be careful not to take too much off, because your walls, your wall count will at some point be depleted. And you will find holes in your lever. Yeah, that's perfect now. There you go. Hardware debugging. And now we can obviously push in our gear here. Cool. Let's put on our back here. Oh, and of course we lost that screw, so, that nut. So make sure that if you put on the back, you don't lose the nut there. So let's turn that this way around. Push that on there. That should keep the nut in place by way of our gear. And then the manual asks us to put in an M3x6 6 button head screws. See if we can find those. Yeah, that looks like a 3x6s. The Bosch has the correct and that's an M3x10. So it's two M3x6s and one M3x10. Because the third bolt is way lower. There we go. 3x6s, we need to get back into this bag. Yeah, M3x8s and where are the M3x10s? That is interesting. I can't see any M3x10s right now. Oh, because they were not where I was looking. Obviously, because otherwise I would have seen them, you'd think. Maybe. There we go. And now we need to center our gear here. The way we're supposed to do this is by looking at the gear and the gear distances. And it's not completely centered there. For the next step, we need to ensure that the 50-tooth gear is not rubbing on any of the plastic parts. It should be generally centered in its available space between the mid-body and the motor plate, as shown below. Make sure the guide door is open so that you can freely adjust the position of the 50-tooth. So, we'll need to open this so we can access the screw, our little set screw down in there. Now it's a very good thing that we have such long screwdrivers to get in there. And a lot of light, because otherwise I can see this being a royal pain. And then we can, now that we have our screwdriver in there, we can loosen it slightly. Push that gear a bit so it centers. I guess it's fine. Not rubbing on anything. Moving freely. And I'm guessing it's kind of being blocked in the front a bit. Oh, wait. Now it is rubbing. So. Bit of a pain to get these set up, I guess. Okay, that is now rubbing somewhere. That's so it feels like this is at an angle somewhat, because one side is rubbing and the other is not. So something must be going on here. And we are we're not actually rubbing on the back plate. So yeah, pain in the ass. People want me. People want me. Don't stream this part. It's a bitch. But yeah, what else do we want to talk about? I mean, I already told you a bit about the streaming setup. We have two OM5s, or rather EM5 Mark IIIs by Olympus still, not by OM Systems. For those who know, I actually like Olympus itself. They used to make good cameras. They still make good cameras. They, from a company politics perspective, they are a bit, I don't know how to say this, difficult. But their gear seems to be solid. And to be honest, I would definitely always stick to Olympus for my video recordings. But I'm actually considering exchanging the cameras here, because they did pull one absolutely dick move. That's something that's currently making my life a bit harder and forcing you to watch in 1080p, because guess what? They think that streaming for 4K is a premium feature. And recording in 4K to a secondary device via HDMI is also a premium feature. So while my EM5 Mark IIIs are able to record in 4K, they aren't actually able to output 4K over HDMI directly. They are, however, able to stream the recorded video in 4K to any TV set, I guess, is the term here. Which means that the camera itself is actually able to transmit 4K, but for some reason they decided that while the extra processing power for playing back compressed video is there, they don't want us to be able to record an incoming video in 4K to a secondary device. And that sucks so much. Really not sure what to think about that. It's like, if you consider that I paid a decent amount of money for those cameras, for those AM5 Mark IIIs. I would have wished that they didn't pull such a shitty move of purposefully disabling that. And they did nothing else. They purposefully disabled that in software. So one of my friends asked me, why don't you just hack that? It's a somewhat risky move, and that it can take a lot of time. We could do that, but I am very likely just going to move to G80s, and that's then also my recommendation for you. If you want a really good portable camera that you just want to take places, record video, really light lens systems, those Olympus cameras still are pretty good. Especially if you're trying to do any kind of vlogging, because they have the in-body image stabilization, and Olympus is just so far in front of everybody else there, at least from what I can tell. But if you are even slightly considering using the same camera to stream 4K, you still want a really small, like the micro. I like the micro four thirds, to be honest. Yeah, if you still want a micro four thirds or really small mirrorless camera to do your streaming as well, do not get an EM5. The currently cheapest option I can find that has decent features for streaming as well as recording video seems to be the Lumix G85 or G80, depending on who you where you are, who you ask. And by the way, that's not rubbing anymore, so I am going to take that. So if actual streaming tickles your fancy, if you want to do that instead, and you want to get a micro four thirds, which by the way I still think is a really cool ecosystem. I wish more camera manufacturers support, then yeah, get a Lumix. They are pretty good in terms of image stabilization now as well. Okay, that's too. That's too tight. I think we need a smaller washer on there. I'm not sure if the if Fysetc actually meant to put in this or to use this nylon washer. I think we're just gonna use one of the M3 washers here. Because that nylon washer is just too big. It's putting too much pressure on the. All right, so open, no friction whatsoever, nice. Close, friction, nice. That should be good. Should be good, and if it's not, we can still fix that later. Moving on, I guess, since we're already 3.5 hours in. Let's see about our filament path. If we can find our filament. There we go. Yeah, that M3 washer actually works better. I wouldn't want to use that nylon washer there. Straighten out our ECAS fitting. Still haven't pushed that all the way in. And that is sitting very well and getting pulled. So let's check the alignment of the gear. Let's take that off. And now I need to shine a light in there. Well, actually, we can probably see this on the overhead as well. Let's go all the way in here. And that is way off. Why the hell is that way off? You see that? Yeah, we need to fix that. Grab your mitts out of the way here. Now, the question is, how do I get the screwdriver in there with you guys seeing that? Because this is kind of sexy. This is kind of what I want you to see. But I guess, alas, it was not to be. Let's take out the filament maybe. That looks better aligned. And yeah, let me quickly get a better grip on this with some actual magnification. That might be the faster way of doing this. I mean, I don't want to bore you with this stuff. Yeah, perfect. Way better. There we go. Now that looks way better. Let me show you. There. You see how that aligns with the filament intake path. We can actually take our filament now. Run that through here. Cool. Well, let me quickly check if that actually is screwed in tightly enough. And yes, me using this actually helps. In my specific case, it might, because it has such a big magnification, it might help others as well. The main thing to always keep in mind is do not hold back when deciding if you need a tool or not to help you. Use all the tools at your disposal. Anything you need. I know this doesn't look sexy, but it is awesome. Because it helps me see things that I otherwise couldn't. Okay, cool. I think we're done with that. Took long enough. Again, we need to add our washer, add our thumb screw. I'm not sure how often I have taken this off now, so they may have had a point when not adding this before. Just saying. Things you learn. this we did correctly actually. We do have like teeth marks on the filament we tested, so that's good. So we can move on to the fans. And by the way, yeah, I am aware that I broke this piece here. We're gonna fix that with a bit of glue. I don't see why we should reprint this just because this small piece is damaged. It does not have any structural impact. It does not have any impact at all on the functionality. It's just this really, really thin little piece. So yeah, just gonna fix that real quick. Here we go. I'm gonna give you a better view again. That's going to cure now. Let's wipe away the excess a bit. And then that's gonna be good again. I mean, it has support from the fans anyways, which we're now going to be adding. Starting with this side, which we want the opening to the bottom. We want it to draw in, so this is the way. Then we want the other side. Oh, and my fingers are slightly sticky from the adhesive now. This one's going to go in this way. The main, I don't want to say problem with that, or the main consideration here though is we need to put in the other fan first. To have that properly connected. And as you can see here, these are actually G-Design fans. They're not the frickin' cheapo fans that Fysetc delivers with these kits. So yeah, that is on purpose. That is actually on purpose, because those El Cheapo fans, they have not worked out well for me on the Trident. They have cost me so much grief. Overhang quality was abysmal. So no matter what kit I get, be it this or the Funsor kit for the salad fork that I already have here as well, that we're building next, they all come with like freaking cheap fans, and I'm not having it. I am really not having it. It's not on my watch. We're gonna use good fans. All right, so fans in. Now we need 3x10 BS button heads again. We move these aside. There we go. That is definitely in. The problem here is to get these in, you need to be a bit flexible, at least for the one. The other one you can take off the frickin' thumb screw again. Which we're definitely gonna do, so we have easier access. And then we can screw in our motor. Whoops. And the interesting thing here is that they are showing the motor without the with the connector pointing upwards, which is only seen there with the four small wires that can come out of it. So let's do that as well. They may have a reason. And we're not going to tighten that all the way. I'm very interested in seeing what these motors can do. Not tightening it all the way. There we go. And let's tighten the other one. Yeah, anyways, we've been talking a bit, not too much, about the streaming setup. Besides the cameras, obviously you know that I have the GH5 here. I use a Samsung Galaxy S9 as a mobile cam. So it's a mobile cam. Working out very well, to be honest. Kind of surprised. It has a very good lens on it, so you can actually put it very much close up to an object, and it will still resolve sharp images. Oh, that feels good as well. Yeah, that feels clean. Really no complaints about that one. I was really surprised how well the S9 does. The software I'm using to connect to the Mac in this case is Camo, which is your typical camera software. Yeah, that was awesome. I have not had any problems with that, much less at least compared to the Elgato software that allows me to use my iPhone as a webcam. And by the way, I still prefer that to the way the iPhone itself allows me to use it as a webcam via the, I don't know, is it continuity? Something like that. Because with this iPhone webcam software, I cannot choose the lens. And if you remember the first stream, and by the way, don't watch that if you don't want to see me babble like an idiot, because I had the audio monitor in my head having a 1 second delay, which is absolutely detrimental to anything you want to say. Yeah, but there we are using the iPhone camera, and for some reason it did not come out very sharp. Cool, that looks good. That looks good. We tighten those. We mesh those. We still have gear meshing it still feels good. We can even put a filament, piece of filament in here and probably draw that in. It's obviously going to be way harder to push that in or pull that in. But it does work. The question is, how do you get it out? And obviously, you can just open it. There we go. But you would not be able to get it out otherwise. Cool. So that's our extruder. What we need to do now is get the Hotend in here. And as I already explained a bit further back, we are going to use the stock Hotend first. I do want to reconsider that because I really don't want to go in here again and replace it with a proper dragon that I know works. But you know, let's run it stock. We have the opportunity. Let's see what the stock Hotend. By the way, with the stock nozzle can do. As you may be able to see, I am, because I'm very often printing abrasives, I am actually using one of those beautiful Diamondback nozzles in this being a 0.6. It's just something that came to be. I like them. I like them a lot. I know they are freaking expensive. The set of nozzles I needed for my printers, and by the way, I only have one MK8 and one MK8 set and one set of V6, where the V6 set contains, let me think here, the V6 set contains the 04, 06 and 1, so 0.4, 0.6 and 1.0. So yeah, that that's basically the limitations we have at the moment. All right. What we need to do now is we need to take off the heater block. Well, I actually don't remember if I already did that, to be honest. The reason why we would is because this comes with an all metal option, but the default option is not all metal. So we have an additional heat break here. You can see it here. This part obviously meant to have PTFE tube in it, and I really don't remember if I already replaced that with a non-PTFE variant. This should be pretty simple to check and potentially do though. So let me put you back on the overhead cam. Let us zoom in here a bit into the chaos. Then we're just loosening the heat break. Now, here's an interesting comparison. These are the two options. One of them being described as the all-metal one, the other one being the default option. Which ones do you guess is which, left or right? Let me know which ones you think is the all-metal one. In the meantime, I'm not going to show you which one I will be putting in here. Well, actually, I will show you because I obviously already did the swap. This side does have the deeper indentation. It's meant to hold a PTFE tube, while this has a chamfer to guide filament in. So while you still put a PTFE tube on top of it here, you don't guide it all the way in. So it is far further removed from the actual heat. And that way, you don't have a problem with running your Hotend at higher temperatures that when heating up PTFE too much would result in dangerous gases. Which brings us to another topic that may be interesting to you, for you to hear. You may have noticed that I am working in the same room as my 3D printers are located. And yes, that is the case. The question that always pops into people's minds, not just in case of my setup, but in case of general setup, is how do you protect yourself from more or less poisoning yourself? And the first thing I want to tell you there is always be safe. Do more rather than less. Try to avoid rooms that you're printing in if you can. Try to make sure those rooms are well ventilated if you can't. In my case, I have two windows that are exactly across from each other. I can push air through the whole room if I want in a very good stream. Let me put you back on this because we're screwing in the Hotend here. So there's considerable airflow when I'm printing. You may have noticed that I opened the window when I was printing earlier. Reason being exactly that, the other window is actually open. And yes, if I'm printing in winter, I need to do that as well. I also have a HEPA filter, like Philips 800-ish, something app controlled. I don't know. It's some Philips job with a big round HEPA filter that I need to clean out every month and replace every year. It's just the way it is. It's like, just need to do it. That will scrub the air, especially right around the printer, but also in general in the room. And it is sized so it can actually cover most of the room within 10 minutes. Sometimes like 10 to 20 minutes it needs to actually completely cycle the air in the room once. At least if I understand the specs correctly, which should be good enough to have anything that escapes the printer trapped inside that HEPA filter pretty quickly. It's located near the printer, so it has a better chance to trap things. That was kind of important for me. So that makes it somewhat easier. I do have a room air quality sensor here. The problem with air quality sensors as you may or may not know, is that your ultrafine particles are not detected by them. My air quality sensor only picks up on until, I think, what is it, 2 micrometers in size. I'm not quite sure. So it's anything PM2, anything PM2, PM5, PM10. The sensor picks up. Anything else it can't. With your 3D printer and the plastic it prints, those plastics actually off-gas smaller particles, and it is much easier to flat out filter those particles than to even detect them. I will at some point, depending somewhat on how well you guys tip here, but also how the content grows, I will be getting a device that may be able to register up until PM 0.3 millimeters, which is ultrafine particles. And I do intend to check around the printer to see what the actual emissions outside are of a sealed printer, or as best as possible sealed printer at least. So that's something that's coming up. I also want to check inside, obviously, because that's kind of interesting as well. But yeah, for reference, by the way, I'm still screwing this in, but I'm not actually showing you. Make sure you have filtration. Make sure you have filtration inside the printer. Make sure you have filtration outside the printer. Inside the printer, I am currently using Nevermore, or one Nevermore rather, which seems to do the job in terms of the general smell, and I suppose with that smell also the majority of poisonous or at least unhealthy things. But just because it's getting the majority doesn't mean that it's getting enough, so I don't get cancer. And I really don't want cancer, so I'm being very careful here. And you should be too. You really should be too. Definitely, and without any reservation, do what's necessary. I will be moving to HEPA filters or HEPA cartridges on my Nevermores, precisely because of that point, because it is just so much easier to filter than to detect. But we're gonna make some, we're gonna experiment somewhat in detection as well. That's gonna be fun. All right, so we got the hot end here. What we still need to do, obviously, is we still need to find our cartridges and put those in. I actually set aside all the electrical stuff, but I guess I shouldn't have done that, because now we need it. By the way, I also usually put a 60-watt heater in here, but I have a bit of a preference for. That's our thermistor. That's our heater. But we're going to use what Fysetc supplied us, and I think even with a 40-watt heater should be fine. should be more than fine actually. Here we go. Heater, thermistor and heater. This actually looks pretty good. I like that a lot. And with this style heater, we don't actually have as much of a problem with them like collecting any kind of fat and then having a bad reaction once they get hot. We want to insert this from the right side, because the flat side is going against the front of the Stealthburner, Mini Stealthburner, and we want to run this up the right side. I usually do anyways. Well, actually, I did this on a pre-build of the salad fork, on an experimental pre-build of the salad fork actually, and it just worked better, worked out better that way. But I guess you can do it the left side as well if you want to balance the cables a bit. But I tend to just have all the cables routed on one side. Thermistor in there as well, and we're going to do this thermistor from the same side. Remember to tighten down both, and don't tighten down the thermistor too much, because I think you can crush these. I'm not going to try right now, but I think you can crush these. This is going to be our Hotend assembly. It's gonna go in here. And by the way, if you haven't already seen the other streams, this has another color. This has a different color from anything else that's actually not visible from the outside. The reason why that is because this was originally meant to go on the salad fork. And I'm stupid. That's the wrong focus ring. There you go. There's the money shot. Yeah. We have these. What we still need to do is put in the PTFE tube. This kit comes with blue PTFE tube for the whole build. I'm actually not as much of a fan of that, to be honest. I would much rather see some clear PTFE tube included in here, because with the blue stuff you just cannot see shit. So what I will do is, I think I still have clear tube, and I also think I still have clear tube that has a smaller, bigger inner diameter. So let's go here. So that's what we want to have in the Hotend, and that's what we potentially want to have in the to guide the filament to the tool head, because this is 4mm outer and 3mm inner diameter, while the slightly less transparent PTFE tube, so this is for inside the tool head, Now you may ask, hey Paul, what gives? Why do you want to have this transparent inside the toolhead? Well, shit can still go wrong. And if shit goes wrong, you want to be able to see where. And it's kind of unlikely that shit goes wrong inside this PTFE tube, which by the way we need to push down and then cut to length as the manual says, to 6 millimeters. Let me zoom you out a bit. So there you go, that's our length. We're going to use our cutter. There we go. This should be fine. This should be fine. And this should be 6 millimeters if we test this now. It's slightly over, but should be good. Remember when you're building your 3D printer. Ooh, that was not what I intended. What happened now? Again, if you're building your 3D printer, you are building a machine that uses its material as flow control. So you're basically using plastic as flow control and cooling, and you're trying to squeeze that in the right position. Obviously that's where your X and Y comes into play. In the right position, through your 0.4 nozzle into the right location. And you're expecting... Oh, okay, so we actually, like, look at that. That definitely needs to be longer. So we need to make sure that we really push that in first, and this piece here we cannot use. So based on that insane premise of a process and its expected precision, and you then also using belts that are fine but not super rigid and not super precise, which belts just aren't by design, I guess. It really doesn't matter if you're half a millimeter off on squaring your frame. Which, by the way, I haven't told you this yet. After we built the frame last week, I measured it, and it is pretty much spot on. There's not even half a millimeter of difference between the front bottom edge, front left bottom edge to the top right back edge versus the other diagonal, and that being below 0.5 millimeter is like sensational. I think it is definitely really good. I'm really happy about that. That much I can tell you. All right, so we have that in there again. Let's screw those down. I'm not using any thread locker or any nail polish on this because I know I'm going to take it off. So I don't want it in there forever. Also, I don't think it's necessary in this case. Similarly to how it isn't necessary to do on the tool head. We'll probably take that apart a couple of times to maintain it, and letting it be without thread locker for the first couple of times, so we have an easier time of maintaining it, might be the thing to do. It's an approach I took on the Trident, and it has worked out very well. I at some point added thread locker, and that worked. Okay, so let's put in the PTFE tube here. Let's really push it in. Let's do this again. Our knifey knife, and where's the calipers? We wanted 6 millimeters. Yeah, but the point being that any precision, no matter how much you add in precision to the process of building your printer, any precision past a certain amount is probably going to be lost in the process. And yes, if you look at the video and look at the playback, I did just stab me with the knife. Shit happens. And no, it didn't penetrate any skin. So, nothing going on. I just felt it poke me. I should still be more careful. This looks good now. This can now slide in here. And it doesn't want to go in. There we go. Nice. Nice, very good. And by the way, if I say we're going to work on this, I am referring to the fact that, for example, we do still want to add LEDs here and here. That's definitely something we're going to do. We're going to run it without for now. Which means that this is basically all the wiring we need. 3 fans and a Hotend and a thermistor. So we can now basically put in the M3x35s. Those are 40s. .35s. There we go. Nice. Like to see those. And yeah, it looks like this is going to be a bit of a longer stream, but because I do still intend to finish up the motors. I do want to get to the cabling and electronics part next time. So we're just gonna push through. The whole build, all in all, I was kind of expecting to be 20 hours because I don't know the topic, I don't know the printer. I think a realistic expectation. And like I said, I'm not actually good at this stuff. I still like doing it. Yeah, and this is where the toolhead ends for now, because now we need the X-axis assembly to bolt it to. But look at that. Isn't that cute? That's our little cat toolhead. Just the way it's supposed to be. With the cabling and everything. What we can still do is add the standoffs. You may have seen in the original that there are standoffs that are printable. Don't print those. They suck. And yes, I did just say that. They really do. Just get these golden standoffs. I know they're not in color, but the plastic ones are basically impossible to print right and still have structurally sound. So I suggest save the filament, get the metal ones. You may be able to get these in black, and I kind of assume that even if you get these in nylon, which you can do, you can get these in black nylon, they're probably still stronger than anything else you can do with those printed ones. The printed ones are just a plague. No mincing words. No two ways about it. All right. Really satisfied with our toolhead. Let's get that printer finished. And I think this will go significantly faster. I am going to clean up a bit here though. And we need to get our printed parts. Look at that. These are fresh from the Trident. Perfect. Love it. That's the way I want those. So let's get back to our manual. Let's finish this up. I already did the bed. I'm gonna make sure that that bed is solid till next week so we can screw it in and add the cabling, but I don't think we need it right now. Doesn't add anything. We have Wagos on the bed anyway, so we can even do cabling without installing the bed itself. So we're back here. I'm going to place the tool head to the side. Oh. There we go, and I will actually place the tool head in the background. There we go. You'll likely not be able to see that well, but who knows? Oh, I mean, once you get to actually see it again. Cleanup's gonna be fun. And I don't even have any whiskey. I don't even have any whiskey. Now that I think about it, that world is cruel to me today. But it is going to go on. So let's not dwell on it. Let's not dwell on it. Let's instead build a really cool printer, which we need to continue right here with our last bearing stack, which means that we need to put the spacer here. Then we need to put our washer there. Bearing, bearing, washer, and then we need to put our. Now here's the question, because I now forgot again which ones are A, which ones are B. We're definitely building the A stack. But I guess we'll just have to check real quick. That looks like an A. Frickin' A. So I guess we're good here. That way around. And then we can just use our Bosch to screw that in. The important thing to keep in mind here, we are screwing into plastic, it seems. So we might not want to do this all that far. Even at the lowest torque, compared to other screwdrivers, this one does have some torque. But ooh, that looks good. Let me maybe zoom out a bit here so you get a bit of a better view. That really looks good. I like that. The bearings are rolling well. The spacer looks awesome. Nice. The manual says to check if that's actually 18 mil or 18 millimeters, because mil and thou are actually measurements of are actually imperial measurements, and as you can see, pretty close. I mean, I'm putting a bit of pressure on that. Awesome. Awesome, that is so good. That is so good. Yeah. So we need another M3x30 set. Where are those? Hello, hello, M3x30s, M3x30s. Your parents are expecting you at the reception area, in the reception area. Please come as soon as you can, they are worried. The hell? That is why I usually have my screws sorted into proper storage, where I exactly know where it is. But for some reason I decided not to do this on this build. And let me tell you, I am slightly, oh, I am blind. I am slightly regretting that right now. And with slightly, I mean a lot. And if you ever find sarcasm in these videos, please keep it. I have enough of it already. These go here. And these are positions where we previously placed heat set inserts. So these don't go into plastic, which also means that we can torque them a bit. And yes, you would expect those to be potentially pushed through the plastic already and just screw into the insert, but alas, no. Also, thinking about it, these, whoops, I will actually pull out, because these are prime candidates to become some wet and wild screws. They really need to be wet and wild. And if you don't know what I mean with that, it's what we do to screws to keep them where they are. Some wet and wild clear will deal with any movement there in a very good fashion, I think. What I'm kind of wondering is how this works though, because usually nail polish needs to be UV activated, and I mean you can leave your nails, not that I do my nails myself, but you can actually leave your nails in the sun to cure them. But how does this stuff cure inside here? Because there is no UV source at all. There we go. I'd be really interested in that. Really. I mean, it does seem to work, but why the hell was it? Why oh why? Okay, and now we need 3x35s, which are not these. Let's just keep those there to actually fasten our motor. That's the motor with the flange down. We need 4 screws. And again, we do need to put those through ABS, so we can actually not apply proper thread locker, but we can apply some Wet and Wild. And actually we can push those through before we apply it. That way it doesn't just go everywhere it wants to, but not where we want it to. So let's just paint our nails or screws, or yeah. There we go. Nail polish applied. Now we need the motor with the flange down, and we need to orient this part correctly so the orientation of our cable is matching the orientation of the screw. Otherwise, I imagine cabling will be a bit of a pain in the butt. And then I can just align it. And screw it in. Now we probably don't want to screw it in all the way. I'm guessing. We don't want to press fit it to this part because the motor is supposed to still move. It's that's what the screw is for tightening that motor. I'm not sure how stable that's gonna be, but we're gonna back them all the way in for now, and then we're going to back it off if we need to. It's a weird concept, but I like it. I like it. It's cool. Oh, and we're actually really stupid because obviously we need to do this again because we're missing a washer underneath those, and that washer is actually pretty important for this to move properly. So we're gonna take all our screws out again. Should have looked at that. If it's not there, the assembly may not be able to slide. The question is, does there also need to be a washer below? But it does not seem that way. So let's find our washers. let's take these. And because we need to assume that the washer needs to slide, so from what I'm noticing, and by the way, I am not an expert in this at all, but from what I'm noticing is that with any washer, it does have a rounded side and it has a stamped side. And since it needs to slide, I assume the rounded side should go down in this case. So it faces the plastic part it's actually supposed to slide on, because I can otherwise see the screw catching on the plastic, and I'm assuming that's not what we want. Just a guess here, just a guess. Yeah. So we're gonna do this again. And yes, we're gonna do the Wet n Wild again as well, because we may have lost that to the to pulling out the screw, at least mostly. Some of it will be left inside the threads, but who knows how much that is. And in this case, I guess it doesn't hurt to use more rather than less. It's not like we're flooding those screw holes or adding anything that will negatively impact the performance here. There. And again, we need to look for the cable orientation. It needs to go in the same orientation as the large yellow screw. And maybe I should actually look if that's probably lined up. Oh, and actually screwing in the screw helps. I've been experimenting in the last few minutes with the auto option here, and to be honest, I don't like it. I like that there's a button on here that says screw in or screw out. The auto option seems somewhat clunky. I don't like it. What I do like is that while this is very, very big and very like unwieldy in your hand, it also gives you purchase to manually screw and tighten things. Just gonna back those off for now, because we will need to belt this. And by the way, one thing to check here, whether we did this correctly, is this pulley. Let me see if I can get this sharper for you. There you go. This pulley needs to align with the gear behind it. So that gear and this pulley need to work together to make your belt move. If those are not on the same height, then you probably mixed up your A and B motors. Which means we get to now build our B motor. We already did a bunch of things here. Already did that. We already did bearing stacks, but we get to now do our, or add our spacer. And while we do that, our screw just goes wild. And it wasn't even wet. Damn you, screw. Let's push that spacer down first. Let's make sure that we add a washer here. Let's add another washer on top. Another bearing. Let's push that screw all the way through. And another bearing. Another washer. And then that's reasonably quickly add our motor assembly so that screw doesn't get any funny ideas. I don't think we need to measure this. I'm pretty sure this is 18 millimeters. I am pretty sure it is. These are all turning freely. So I guess it's time for another 3x30s. Which will go here. And again, since these are going through ABS, we still want to thread lock those. In this case, we don't have a choice. We need to do this right now because we can't do it once it went through the first bit of plastic. So yeah, going in here. Get those started, and that will then lock down this part. There you are. Now it's in there. Now that's in there as well. We're going to really tighten those because it's against heat sets. And now we get to do our motor screws. "25s, where are the 35s? Wah! Where are the freaking 35s? Going nuts here. These are the ones. These are the ones. Again, from the top after we add a washer from the top. Washer important. Washer very important. One washer. Two. Kind of wondering if Nero already started streaming. But hey, not doing this for the fame. Again, by the way, just to make sure this comes across, if you like this, if you like the stream, if you're watching it and you actually like what I'm doing, you want to see more, you think there's potential here even, right? It doesn't need to be perfect, but if it's not, then, well, I actually expect it to not be perfect, but if you find specific things that bug you, put it in the comments. If you like what you're seeing in general, if you find potential here, like, share, subscribe. If you think it's worth it and you want to invest in me, obviously under the guidance and watchful eye of Enek, doing this any further, please tip us. And yeah, that definitely helps support future projects, because obviously this stuff can get reasonably expensive, and I'd rather see you support us than a company. Not that I don't mind companies, and I'm certainly going to be very grateful to companies that support us here, but the more independence I can derive from user participation, let's put it that way, the less dependent I will be on companies. Obviously, I cannot be bought. But yeah, that's just my take. Take that as you will. Take that as you will. All right, put that together as well. It barely slides, it is thread locked. We have our motor here with the cables. Let's put that on the printer. Yeah, we did that. We did that already. Go. Now, I'm guessing we need to back out the screws a bit here. By the way, I will remove the remaining spacers here. Ooh. Chaos. That can actually go back here. Oh, I like that. I like that. That is so freaking cool. Screw to the back, yeah. Let me see if I can. Well, actually, we don't need the soldering pad anymore. So let's just get rid of that. There you go. And now let's look at this here. What we have here is basically 2 screws, and I imagine that if we put these screws to the front, that's where we're gonna need those, and this one to the back. And I am guessing that we're going to screw our assembly in this way. Just a guess. So this is a bit of an interesting one, and that's I'm not gonna use the electric screwdriver for that, because it might shake those screws and nuts in a way that makes them move. And my back screw does not thread well into the extrusion. What the hell? There we go. Now it's threaded in well, which we're gonna take out because I obviously forgot to apply some Wet n Wild to them. As usually, me being an idiot, that's what happens. Again. I, by the way, like how they designed this step, at least to some degree, because what they have you do is first align your one nut and your back nut with your elements here, and then in a second step deal with the second set of preloaded nuts, instead of having to align all the nuts at the same time, which I'm guessing would be a pain in the butt. But yeah, these motors need to sit really well in here. That looks really good. There we go. Now they also want us to add some more 35s. So we're gonna. Again, some Wet n Wild. The challenge now will be that we will need to move some nuts below them. I think on this one I already got that. Yes, I did. And here we still need to move that below there. And we'll see if that was enough. Oh yes, it was. The Wet n Wild will obviously keep this stuff where it's supposed to be. Very secure. And we're making sure that the movement of the bearing stacks is not impeded, which it isn't. That feels so good. That feels so good. You cannot imagine how good that feels. This is going to be an absolutely awesome printer. I am really excited to actually have a really small printer that I can just put beside my desk. By the way, this goes even to the, like we talked about it earlier, about filtration and making sure that you don't poison yourself. it is much easier for an air filter to filter the volume you find in a V0 than in your Trident or V2 that's 300 to 350 millimeters. Like, that difference must be so huge. Actually, so yeah, the same Nevermore with potential HEPA filter inside your V0 may actually protect you better than if it is installed in a V2 or Trident with its huge volume. One more reason to build small printers. I already talked about that a bit. I am a very big fan of building the smallest printer possible for your use case, which, by the way, is probably around the 180 mark. Because what many people don't consider is that even if you build a smaller printer, and by the way, that smaller printer is still going to be completely sufficient for the for most of the STLs of the month. But you can also go and just weld, like acetone weld your prints if you want to build something bigger. You don't need to actually print that big helmet in one go. You may not even want to print that big helmet in one go. I mean, why would you? Especially if you're printing in ABS. Acetone welding results in a really strong connection, so there's almost no reason why you'd even really need to do that. And on the flip side, if you make the clever and sensitive choice of going with a smaller printer, well, actually, if it's really just the very few prints, right? If you want to print helmets up and down, then you may be better off with a larger printer, right? I don't deny that there are use cases for that, but still, most of the time, you're very much going to benefit from a small printer. Most people will be better off with those. And by the way, I have this arm here slightly crooked, which is why I'm currently trying to readjust it, otherwise the last screw will not fit. That, by the way, being one of the downsides of how the Voron team decided to have this assembled. Because it only aligns on this one edge. That's an interesting one. Let me use a proper smaller screwdriver here. Yeah, there we go. That's going to pull that straight. Or not. Nope, we're gonna take this off. And then we're gonna do that again. Because I don't know where that nut is. And I want this done perfectly. Because it's our AB motors. Nope, not coming out of there. So let's take it off. Let's just take it off. Let's make sure that we have these in there talking down as best as possible. Ah, there's our nut. Nice of you to show your face. Let's see if this nut is still in there. Kinda guessing it isn't. There we go. Got our nuts free. Now back to our Wet n Wild screws. Well, actually, that may also have moved, so yeah, it has. It so did. There we go. Got that aligned. And you can't see shit. Ah, oh, damn it. Got that aligned as well. Now, let's move that one under here again. Yeah, this is kind of difficult, to be honest. Shit. I'm guessing that moved again. The B-side actually went on really well, really quickly. But yeah, let's maybe line all of them up exactly where they need to go. And let's get everything started. Oh, damn it. Ooh, that's in there. That is in there. That really is in there. That's easy. That's in there. This is not easy. So if you're doing your 3D printer build, if you're doing your V0 build, this is probably not the step to look forward to. but at least we got that screw out. Maybe we can do it from this side. Maybe that's the better ticket. That should be it. There we go. I think that's it. I hate this step. Yeah, this sucks. This is the most annoying step in the whole assembly right now. Getting all these frickin' screws under here. Whoever thought of that? Well, we know who. I mean, this is Rancher's baby, I think. And it flipped out again. Ooh, am I annoyed? By the way, the way to solve this, or one potential way to solve this, would be to have some kind of indexing on the bottom that does not, that locks the screws in place where you want them, kind of like the no drop nuts and no drop nuts. Which, by the way, brings up another topic. I looked a bit closer, and even the extruders we have may be able to use those. Okay. So I'm really not sure anymore. The only thing I am sure about is that on the... Nice, now it's in there. And it really is. The only thing I'm sure of is that we can't use the ones that were made for the salad fork, because those are already tried with the salad fork extrusions, and it pains me to say, out of luck there. Although, to be honest, I haven't, like, except for our escapades of those 5 nuts escaping from the Z rail during assembly. Shit happens. It took us maybe half an hour longer. It was annoying as heck, but in the end we made it. By the way, we also made it here. We did it. Motors are on. Motors are on. Let's move on. Let's see how far we can still get. More bearing stacks. Cool. And yes, this is a longer stream again, because I want to finish the frickin' printer. I want my toy, essentially. My feet kind of hurt, but no pain, no gain. I definitely want to see the x-axis and the toolhead mounted. Okay, so we have this part and we have a larger one that is this part. They both get a an M3 by 35 inserted. Those are 40s, those are 35s. And once the 35 is in there, we get to flip them around. And I think I will quickly clean those up. I'd rather have a slightly chamfered edge than an elephant foot, so. And yes, I so want to do electronics. There we go. And yeah, by the way, if we can actually get the to the wiring next week, we will have to have a bit of a talk about wiring regulation and safety. Now, keep in mind, I am not a licensed electrician. But since this has been the topic many times, the thing is, in Europe it is, and especially in Germany, it is effectively not allowed to use your own electronics at all, and plug them into the general net, into the general mains. The way that this is being treated, however, is by reacting to results. So there are no preventative measures taken. So if you can build a 3D printer that doesn't burn down your house, and your house does not burn down for any other reason, you're good, because nobody will actively come and check your house, your installation, your whatever, if it is not a commercial installation, if it is not an installation that is open to the public, or that you're in any way trying to sell or market. So essentially, in your own home, you are allowed to do what you need or want to do. Now, that only goes as long as your house does not burn down, or as long as you don't have any damages that are traceable to any of the that are not in any way traceable to the things you did, the things you built. So if there's if there's no issue, you can do whatever. If you really want to have your 3D printer, or any 3D printer, used in installations, used anywhere where it is accessible to the public, anywhere where it's not in your private home, that's a different story, because then you really need to abide by the laws and the VDE for Germany specifically. Now, this is not in any way to be construed as legal advice. That's, I think, a given, right? Because you will definitely always be the only one responsible for your decisions and for the fate that results from those. But if you do your wiring in a way that is actually VDA and general rules and regulations compliant, then you should not have any trouble. Now, the way to really do this, the way to actually be safe and also retain your insurance, because your insurance is definitely going to use any way they can, even if your 3D printer does not have any impact on any damages that you may have incurred. Your insurance is still trying to potentially back out of any liabilities they may have to reimburse you for your damage. So the way to really be on the safe side is to actually have an electrician check your installation and certify it. The easiest way to doing this would be if you know somebody in your family who does this, which is the way I go. I do build these things, and I will build this one on stream, and I will likely not publish the corrections that I needed to make to have that specific family member certify this build. That's up to you. But in general, if you really want to be on the very safe side, get yourself an electrician, talk to them about what it would take for them to certify your home installation, and let them check it. Because what you get out of this is not just safety for yourself and your family. Not just the insurance, but also the safety of your protection for you and your family. Because no matter how careful you are, no matter how much you think you know about wiring and electricity, and I would say I know a considerable deal. This machine is going to run on a significant energy source. It is going to produce heat, and it is dangerous. It is a robot. So let's say even if you don't want to get it certified, at least have somebody check what you did here. At the very least, let somebody check. Really. It's peace of mind. It really is peace of mind, and you should really do it. Oi. Somebody had too much fun here. Uh-oh. Let me quickly check what happened here. Nah, I guess it's fine. That Enek. All right, so we have the front idler assemblies. These back for some wet and wild screws. So let's give them one, give them some. Let's give it to them, yeah. Some very juvenile humor here. But that's probably why you're coming back, be honest. Be honest, that's exactly why you're coming back. So yeah, let's move on. We got that, and now we want to place this here. That is awesome. Then we want to screw that down. You know what? I don't like this. I'm gonna take it off again. And then I'm gonna put in that, what is it? M35, M3x35 before we screw down the first one. Because then that can get some wet and wild on it as well. And I like that. I like that a lot. I want that to be done that way. Also, it gives me a chance to really line up that nut already. Come to think of it, it is actually better, I think, to line up and screw in this one first, because then you can line up that nut with the screw, and then move that over the end of the other extrusion, because the extrusion has a fixed end that we exactly know where it is. So I'm kind of thinking it might be better to actually use that to our advantage. Let's see if that is an advantage. There we go. Some freshly wet screws. Fucking A. These stupid screws. Yeah, that worked. That actually worked beautifully. I like that. Really on there. That's not going anywhere. Yeah, that's the ticket. Lining up the second screw and then getting both started before you screw down the first one. That works so well. And yes, I am still not using the electric screwdriver in this case. Mainly because I fear that the electric screwdriver may rattle the preloaded nuts in the extrusions to an extent where they're not where they're supposed to be anymore. And that would then suck. Because finding those, especially under the printed parts, not my definition of fun. Yeah, that one moved. Oh, I love it. I love it. This looks really good. Awesome. Kind of hoping that these don't have a direction. Or that I picked the right direction. I think I picked the right direction. Well, we'll see. We'll see. Yeah, we did that already. And they ask us to check. Yeah, That's right. That's correct as well. Nice. Nice, nice, nice. Yes, that is exactly what that looks like. Yeah. Yeah, yeah. Oh, and now we're doing Z. Jumping around here a bit. Okay, so we need to find our M3x12s and the nut for the Z. And they, by the way, in this case come in 2 pieces with these no backlash nuts. Which means that the larger part likely needs to go up and the smaller one needs to go down. And then you compress them as much as you can. All right, let's do it. Let's do it. That doesn't need to be there. And by the way, really stoked how this is turning out. We only need this part then. And that seems to have some kind of threads already in there. The 12s BSC. BHCS. 2 pieces, and we need to get those in here. Yep. Easy. Easy. All right. Yeah, that's reasonably simple. They also ask us to put these in. We already did that, so it's already on there. We're also being asked to preload 3 M3 nuts. They ask us to turn this around, and I guess things are getting nutty again. That is so nuts. So 3 M3s each side, basically. That makes sense. 1, 2, 3. 3. Need some more nuts. That's so nuts. 1, 2, 3. 1, 2, 3. This I assume is for the panels. I'm guessing they will ask us to exactly do the same thing for the other side as well. So there we go. And we're also going to be asked to put in 4 on one side and 3 on the other on the back. 2, 3, 1. 2, 3. And on this side, we need 1 more. They say. I'm assuming that's for the spool holder. Not quite a fan of the spool holder being in the back, but I guess it's okay. We'll figure it out. It's actually not too hard to preload something else here because you just need to take off the foot. It's quite a different story if you had to take off one of these. So these I don't mind. We can potentially modify something in there as well. Nice. So we have 3 here. We have 3 here. We have 3 here. We have that on the other side as well. We have 1 nut in the back in the middle. We have 2 nuts in the back bottom row. 3 nuts down, 4 nuts down there. So, cool. They are also asking us if we have 4 nuts there on the inside. And that may have been something we missed. Let us check that real quick. Because I wouldn't even know what needs to go there. Let's make sure that I'm not even sure what goes there. But it's probably the door, which means that just to be on the safe side, and because we're absolute masochists, we're going to mount the feet first, just so our now preloaded nuts don't get away from us. And then we're going to immediately preload that one side. We already did the heat set inserts. So it's time for the feet. And we're being asked to mount the actual feet first, which means that we would need to find them, but screw the feet. We can still mount them later. I'm not in a hurry to mount those. We're also not building that. What we do want to do is we want to find our M3x10s. And we want to make good use of some preloaded nuts. M3x10s. Actually, we need some M3x30s, 40s first, which I always find when I don't need them. And I find them when I need them. Nice. We need 4. And again, we're going to use some Wet n Wild here. To get this mounted. The IDC outlet, I hope that's the correct one, by the way. I'm not sure. And I don't like how that's sitting, because it is protruding past the end of it. And I know exactly why that is. It is because the other side warped. The standoffs are considerably warped here because they're getting so thin on the end. So we need to quickly clean those off. That gives us a chance to also very quickly make sure that we add a bit of a nice bezel here instead of having this elephant's foot. And by the way, if you're seeing any discoloration right now on the things that we deburr here, that's because the ABS and ASA discolor under significant forces and significant impact. You can easily fix that by just heating that up real quick. I think the printer's gonna take care of that for us. Mostly anyways. That's on there, nice. And by the way, due to the current time, we are also not going to worry about any of the skirts right now. The skirts we're probably gonna put on all the way at the end anyways. Not sure if that's already part of the manual beforehand. Same with the feet. Well, it started a bit slow this stream. It went a bit slow, and now we're in a hurry. Just as real life. Kidding, of course. Look at that, that is awesome. That is such a cutie of a little printer. But this has a bit of an ugly elephant's foot here. There we go. Last foot. And yes, as previously mentioned, this is a foot without the filament sensor and filament guide. We'll need to find another way in for the filament. Not sure how that's gonna go yet, but we'll figure it out. Cool. Feet are on. We're really getting there. So I actually really want to add those. What's that? M2x10 self-tapping. Yeah, come on, come on. We're gonna add our accent pieces here. I really want to add our accent pieces. I really want to. Kind of curious to see if those self-tappers will be enough now that we took two away for the filament sensor in the toolhead. Kind of hoping that that will still be the case. And by the way, for self-tappers, this electric screwdriver is absolutely useless. So I guess we're gonna switch to the VR. There we go. There we go. I so like how this turns out. in terms of the colors. Oh, but I am being stupid right now because that does not work. That's the ticket. See, that's why somebody needs to be in the chat. Nobody here yet. So if you're seeing this post the actual streaming date, subscribe. You'll likely get a notification that we're going live 7 p.m. Central Europe on Saturdays, or 6 p.m. UK, or 1 p.m. East Coast, or 9 a.m. West Coast. So again, really sorry to those West Coast night owls. If you want to catch a stream, you will have to get up a bit early. And I know that Saturday morning stream watching might not be the thing you want to do. I just can't do anything about that at the moment because I do have other responsibilities that I do need to take care of during the week. And it is an absolutely insanely stupid idea to stream during the one other time I could potentially stream, which is Sundays at the same time, because that is Steve's slot and I really don't want to take that from him. Well, not that I could, right? But I don't even want to compete for that, really, because I think Steve is awesome. He is absolutely OCD. He really has this hardware thing, and making hardware done and dialed. So, respect. We may be able to stream on Fridays as well, but obviously some people will still be working on Fridays, I hope, and I do not want to be the reason why you lose your job. I really don't want to be that guy. And obviously you shouldn't risk it. Alright, so feet are on, the only thing we should still do. And by the way, this now secures our preloaded nuts, so by now we can do things again. So now we're gonna grab our by 10s and 3x10s, that is. And we are going to fasten that power input. So that doesn't go anywhere. Once we've done that, gonna add that here again. The question is, where's the other nut now? There it is. Again, there's still ABS involved, so still no thread locker. That was a bit much. So we now have a wet and wild placemat here, or ESD mat actually. I hope things don't get rowdy now. Oh, and that's in there. No, it's not. That does not seem to hit the nut. Well, let's put in the other screw first. So we have things in place, and once we have things in place, then we can fiddle with our nuts. And yes, I just said that. Let's fiddle with our nuts. We could also, and this is just a wild thought, we could try out our whoops. Oh, that's not good. That is not good. Oh, look at that. So if that's already locking that nut in place, maybe we should screw that out further. See, that worked out pretty well. This one, yeah, to be honest, I don't like that. I'm tempted to take that off again. And I mean completely. Although I really don't know how you're supposed to properly line those up. Let me get there with some magnification. And let me see what's going on. Oh, that's going on. The nut was already where we wanted it. It was just hidden very well. I guess we're dealing with ninja nuts. And by the way, in this case, there literally was no reason not to key this in a way where that nut could move past where it's supposed to sit. I think that's a change that should be made here. Because this, actually, come to think of it, I picked this screw from the table, not from the back. So what we actually should do is grab one from the back. We'll move that back there. Magnetize this. Wet and Wild on the screw, because we really want to lock this machine down. Then move that into place. And here we go. I guess that screw was bad. That screw was bad. I checked it, it was the same length, but I'm pretty sure if I look at the threads, the bottom ones are just gone. Which means you don't even get it started. And with this somewhat warped object or print, that might actually be a bit of a problem. Yeah. Now, since we have the nuts on the bottom locked in place now, we can actually go all the way to the top again and look at the preloaded nuts that we were supposed to add here. And we're supposed to add those on the side that has the higher stack, which means we're actually going to push this out again. We're going to take this off. The sad and heavy hard, are we going to take off our idler? That's only 2 screws. I guess we're fine. There we go. And now we're gonna go nuts again. If we can find them, that is. Hey, Nuts. Wasn't there a Final Fantasy character named Nuts? Or am I remembering that wrong? I think so. There was. Hicks and Wedge definitely important. But I think there was also a nuts at some point. And yes, if you haven't played Final Fantasy yet in any incarnation, try 7, try 9. They're awesome. Those were kind of my first games that I developed myself. Was clones of Final Fantasy. They never saw the light of day. They just gave me a really good experience in how stuff like that needs to be built by recreating those game systems. Back then, when we still had Java Mobile Edition, and you had to package your game, your whole game, in 1.5 megabytes of space and had kilobytes of memory. Those were the good days. Back then by the way, we got our nuts in. No? Yes? Yes, we got our 4 nuts in there now. So no big deal. I'm assuming that Wet n Wild still isn't dry, so we're not going to reapply it. Because I forgot and I need an excuse not to take that off again. So, we get to play with our Zee Motor. Nice. Zee Motor. And Zee Motor Mount. And M3x6s. That should be easy. But yeah, I'm really happy how that's turning out. Three 12s, 3 8s, 3 6s. This is going to be such a good printer. And yeah, Nera's probably going to build a better one. Steve, anyone who has experience building things will probably be able to recognize more details, more important details, and be in conclusion able to build a better printer, or at least build the same quality faster. Right, that's they are like input shaping. They already know where all the corners are that need to be cut and navigated. But I'm still having fun here. I am still having fun. And while I can see people still don't seem to be interested in the content here, for whatever reason, you bastards. Kidding, of course. I can totally see why. I mean, this is the umpteenth V0 build, so why the hell would you watch that as well? You probably built one already, or 2, or 15. Oh fuck! I think I just stripped my stepper. That ain't good. That sucks. That would suck so hard. Nah, I think I'm good. I'm just gonna take another 3x6. That for some reason I just had in hand and can't find anymore. This is... I guess we're screwed. This is nuts. That's empty, so... Probably just a bad screw. So we're gonna do Wet n Wild again. Yeah, the point I was going to make is yes, you can get some more tricks from them. You can also see from me where I'm stumbling and what my end result is going to be, if you're interested. If you're so inclined. See? That still holds very firmly. Nice. And the Wet n Wild will do the rest. So no problem at all. Yeah, if you want to see a fast build with fast results, I guess those guys are really the better choice. If you want to see engineering approach to a new problem by somebody who literally has no prior experience building things, you're right here. Oh, they're even meant to be M8s. Damn it. Fuck, that explains so much. I was thinking they were too sharp. Because the back one, and by the way, this is really important. Look at this back one. This is really short, but the side ones are really long, so they actually don't grip as well. So I was kind of trusting the engineer here, and the engineer trusted that I'm able to read, which apparently I'm not. But see? That's why this stream is still interesting. I think. And by the way, I also think we have a really good speed in terms of people actually joining in and following along. So if you want to, that would be awesome. You can even be faster than me. I don't mind that at all. Rub it in my face. Make sure I understand. We'll see who laughs last once we run through this whole software gig. Because that's likely when we will pick up some speed here. I hope. Right, wishful thinking. There we go. Yeah, this is better. This is so much better. I can actually torque these down now. I can like really wrench on these, so they sit really well in there. This makes so much more sense. There we go, and this is freaking solid. All right, guess we need to Now turn the printer upside down again. By the way, I love this build. This build is amazing. It is just so awesome because the printer weighs basically nothing. It is so easy to handle. The only thing that is majorly annoying are my nuts. Those nuts are a freaking pest. And that's M3x8s, and those are M3x8s as well. Yeah, to be frank, it's I'm looking forward to the salad fork build because it's a smaller Trident, and I think the Trident platform is really good. But if you really want to build a printer, and especially if it's your first one, I hinted on that in a prior stream as well, I think. Small. The smaller the better. As small as you can get away with. Oh no! So, anyways, that's the gist. Build smaller printers. Again, LDO, Fysetc, whoever. The printer I would like to have most is a DC bed 18mm, 180mm cube print volume, or even 180mm by 250 high. Trident platform. 2020 extrusions. All the good stuff. Easy modability, easy maintainability. I don't mind a Mini Stealthburner. I don't mind a real Stealthburner either. Like whatever suits you best there. Ooh, that's gonna be a pain. That is gonna be a real pain. Actually, that's gonna be such a pain that I think in this case the manual might be right in that you should probably do those first and these here in a second step. Which is still gonna be a bitch to line up those screws. Damn. Who the hell thought of that? Yeah, so what you want to do here basically is line up all the nuts at once. so you can, and I'm sorry I can't show you this all the way, but you basically want to align the top nuts, then screw those, then align the front nuts as well. Actually, I can show you this. Let me see here. And you're going to also then see so basically you want to align these exactly to the holes there, and you want to align the you want to align the ones that are down here. See those on the bottom rail as well, and then just don't move the printer, screw those in. Let's see if we can make that happen. Let's see how well that works. And yes, I'm going to use magnification. I just put that on to really get in here, get this thing all the way aligned. And I already lost one of my nuts again. There it is. And now we're gonna align that. Align that as best as possible. Align that, and that's a bit of a pain. This one hides, so we need to use tweezers to get it out of there. Put that there, and now nobody move, nobody sneeze, nobody do anything until we have that motor firmly in place. Few adjustments here and there, and by the way, we don't need them completely in the right position. We just need to be able to grab them. And if the all the way outer one is still not aligned properly, that's fine. So the bottom right one doesn't necessarily need to be aligned, but all the others need to. There's just no other way. That is insane. That is such a terribly difficult step. That's made even worse by the back plate, by the bottom plate being there already. I hope that those nuts are staying put. I really hope those nuts are staying put. By the way, I don't need the magnification anymore. So it's fine right now. first one's on there. And in there. I will have to check if Srancho was responsible for designing that salad fork as well, I think. So I know what I'm getting myself into. Oh yes. That is in there. And that ain't. Yes, it is. Oof. All right. All right, all right, all right. We got there. We got there. Now for the last critical one. I'm pretty sure there must be a trick to this. I just don't know it. I guess we need to put that up. I will also put you back on this camera. I see the problem there. No. I shouldn't be able to do that. Frickin' A! This is so hard. This is so hard to do. We'll need to keep those in there. But maybe, just maybe, that one's in the right position now. And I hope that's actually the right screw, the right nut. Because if we screw the wrong nuts, we're gonna have a problem. Especially if they then are wet and wild. But no, we're good. We have a winner. We won. Yes, nice. All right. Haha. We got there. So yeah, the trick is to align at least 3 and get those done. The fourth one pops into place relatively easy. That's nice. Oh. I still hate whoever designed this because this was way harder than it needed to be. Well, no, I guess they will have thought of that, but that was definitely not easy. But we have Z axis. Now what we can do now is we can actually add the no backlash nut. I'm pretty sure that needs to interlock with the nut below so it doesn't get pushed away. I hope I added that correctly because I really don't want to take this off. I think I well, we'll see. Yeah, that's kind of what I figured. This should have been on there already, or as well. This should have been on there, and the question is, do I have any chance in hell of taking that Zee motor off without going through the same steps again? And I guess not. So, yeah. Yeah, that is definitely a design flaw, I think. That I cannot actually take the Zee motor off without completely disassembling this insanely difficult to assemble piece. But what we can actually do, now that I think about it, is we can take off this part from the bed. Haha. Our bed will drop. And this goes up. And now we can actually put that all the way in so that these small tabs interlock and screw that back down. And then screw it back into the bed. There we go. Whoa. What an ordeal. No, actually, this was a pretty sweet solution. And I'm guessing that's actually how a no backlash nut's supposed to work, because it needs to somehow stay connected to its lower part, and it will just make sure that it always has pressure on that lower part to move it all the way down. Awesome. Nice. That's how you do it. That is how it's done. And by the way, this picture here is actually showing what I mean with the tabs there, with the no backlash nut. So cool. We're supposed to loosen our screws here a bit. We can definitely do that. I guess this adds to the compliance that the ABS part here already added. We'll see. We'll see. Yeah, and we're supposed to loosen that all the way. Move the bed assembly all the way down so it doesn't bind. Because the assumption is that your bed assembly has the least amount of freedom of movement all the way at the bottom, where you have the lead screw between the motor and the bed mount be the shortest. So what you're basically trying to do is make sure it aligns there, and then you're relying on the flex in the lead screw to also work all the way up. Right, the further up you go, you can see it here, the more your lead screw can move, so the less it can actually bind up. But all the way at the bottom, you have the biggest chance of binding issues. So we're gonna do this again. Gonna unscrew these because there's still a bit of additional friction, I feel. We're gonna wiggle the whole thing. By the way, why is my perfectly square? Oh. Yeah. That is weird. Oh, we'll figure it out. We'll figure it out. Anyways, we wiggle this around, make sure it centers naturally. Then tighten the no backlash nut back down. There we go. Here we go. Whoops. That should be fine now. So there. Yeah, that feels good. That feels good. We're also going to loop the lead screw, but not yet, because if we do it right now, we're going to get that loop just about everywhere. So instead, we're going to do our x-axis. That should go reasonably quickly. And this is, by the way, going to be awesome, because now the printer is coming together. I guess next time we're going to do belting and electronics, because I'm pretty sure that while we already built our tool head to most of the extent, we're not going to get those belts in today. But we're at least going to mount the x-axis. And maybe even get that tool head screwed on there for show. For real, for show. Yeah, so for me, it's kind of getting late, so I may be shutting up somewhat. I will still add you the chapters as soon as I can. And I think I want to add the skirts. Just because I can. Later. One step after another. And that actually was not the plan. There we go. That was the plan. I guess that's that. That fits perfectly here. Or we'll see. Here. That makes sense. Ooh, so okay. And we need 3 by 25s. I saw those already. Question is, where are they now? And 3/14s. And 3/16s. 12s. Probably all the way here. Yes, M3/25s. And we're asked to use this part with these screws going here and here. I guess we're using the electric screwdriver again. There we go. And even here, I would stop as soon as we touch. Right, so don't go too far. There's no need for it, I think. Then they turn it around, and we need a spacer, then a bearing stack on the one side, and a bearing stack, then a spacer on the other, which means we need our washers. Oh no, there they are. So as goes with all Vorons and I guess most other 3D printers, washer. Actually, let me show you this on the big one. Here we go. So washer, one bearing, another bearing, and another washer, and more or less the same thing we want to do for this one as well. We want to add a washer. That was not what adding a washer should look like, so if you try to add a washer, maybe try to pin it to the post. So washer, bearing with the flange down, bearing with the flange up, and another washer. That is the first thing I learned about Vorons, is those stacks and how those need to go. There we go. And if we look at this from the side now, we can see that these are the bearings for our A and B motors. Although, and this is something, correct me if I'm wrong here, I'm seeing that there are 2 washers per tower, up above and down below. So I guess we need to add another washer per. So this actually goes against how Vorons usually do their bearing stacks. But that is insane. Who designed this? No way. How can somebody who designs a free 3D printer model be this inconsistent? And yes, I will need to check if that was the case on the other one as well, just to be sure, because I did use a standard Voron bearing stack there. So this is page 115. Let's quickly check the AV motors. No, we're good. We are good. And by the way, I am very pleasantly surprised. We're streaming more than 6 hours now. 7? More than 7. And I'm still having fun. By the way, the reason why I'm streaming still is because once I stop, I have to wait a week to continue this. So I guess you're in luck. Yeah, now that we fixed our bearing stack, we can basically put it together. And I'll switch you back to the manual cam. We do actually have threaded inserts that you're screwing into. So while this is ABS and we do need to avoid thread locker outright, we do want to do wet and wild on here, but we need to be extremely careful that we only dip it in the end. We don't want that going down the screw. And then we can put that together, I guess. Oh. That does not look correct. Yeah, that doesn't look right. That is the wrong part. That's the correct one. There we go. That looks so much better. So we got this part, and then just for securing the post, and by the way, we do need to check if these run freely, which they do perfectly. So good. We're gonna measure the distance in a second, but we're also asked to ram self-tapper down the post to secure that in place. So let's screw that. And yes, this I think it's a wow stick clone or something along those lines. Is pitiful. It's probably really good for doing really small screws. But it is abysmally bad for anything bigger. Ooh. And that feels so good. You have no idea how smooth that is. Alright, so I guess the other side? Oh, we wanted to measure how much of a distance we have between those. And we're currently at 18.5. $18.91. So wait, they're asking us specifically to check this side. So that's 18.5-ish. I guess we can back out those screws a bit to get it to 19. Because A, we Loctited those, and B, they probably don't need to be all that fixed in place. So yeah, that should be good. I am assuming that it is actually okay for those to be not fully torqued down. I hope that's actually the case, otherwise printer may not be going as fast as we wanted. And we want the printer to go fast. Let's assemble the other side. Should be reasonably quick. That'll allow us to put the x-axis in with the nut bars. There we go. And this one as well. And this time around we need another 2 spacers. Good thing we printed 6. Spacer here first. The other one gets the bearing stack first. Same thing here with the double shims. Now the main question becomes, who the hell ate my bearings? These are empty. There might be 4 left here. Yes, there are 4 left there. Nice. So, can actually put you back on this. I already added two shims. Oh, wait. That's the wrong one. Damn it. Somebody tried to be cool and screwed it up. So, we're gonna try this again. Here we go. I already added the 2 shims. Now we need to add the first bearing with the flange down, second bearing flange up. We're gonna add the first shim, second shim. And there we go. The other one, same deal. I'm gonna add the first 2 shims here. Then the 2 bearings. And another 2 shims. And then obviously on this side we need to add the spacer on top. And when we add the mount on top, screw that down. Should be good. And let me put you back on a different camera. Whoops. That had a bit of force behind it. Good thing this is already somewhat assembled. I think I'm going to rather take this to get this started. I mean, we don't even want to have this all that tight, I guess. Same as with the other side. The distance between the upper half and the lower half actually matters. And the control over that, obviously done by those screws in relation to the self-tapper that we're going to add now. Let's see here. Yes, we are going to add that. So we need our screwdriver here. This side. There we go. That should be good. Now let's measure it. They're asking us to again measure this side. I guess we can still go a bit out on that one. Still can go a bit out that side. Yep. Both are running freely, very freely. So that's cool. And now it's going to be completely nut bar, which means that we need our nuts, we need our rail, for the nut bars on the rail. Of course, we are going to use proper Loctite. And as shown in the picture, we're gonna put in every single screw. We also, as the picture rightly shows, are going to need our alignment jigs. There we go. Those are the correct ones. So, gonna push that aside a bit. By the way, this is what we're looking at right now. And as last time, I'm just gonna push some Loctite in here to make sure that there is some in, and then we're gonna clean it off after, just by wiping off the top surface. That should still leave enough of it in the actual screw, in the actual there we go. 1, 2, 3, 4, 5, 6. No, 5. It is interesting that they chose to here use every single screw. They're usually every second screw. And by the way, I may, like in the first and I think also in the second episode, I posed the question on why they would have chosen to put Kapton tape on the bottom of these. I kind of have an idea now why that might be. I'm kind of imagining what this whole procedure here with the Loctite would look like if that tape wasn't there. I'm guessing they meant to protect the work surface from people spilling their Loctite down the bottom. This is a B. We're not dealing with Bs. We're only dealing with As. There we go. That's our A extrusion. Same thing as last time. Those in. Now we need to find ourselves a pack of 2x6s, I think. Let's take these. And I guess we're screwing those in with the, where is the Snapmaker screwdriver? By the way, I'm still not sure what to think of my Snapmaker, but their screwdriver is just awesome. There we go. That was the first one. That's the first one on this side. Nothing fixed yet. I mean, these are still pretty loose. In and backed off. Remember, this is a rail, so we want to mount that actually from the inside out. The only reason why I did this from the outside in right now is because I'm actually not tightening them. We're going to move this rail around. Here we go. And we're going to populate those outer ones when we actually have some end stops in place, so we don't lose our carriage to excessive fall damage, as it used to be in games. Nowadays you just get blocked by the ledge. And we're preloading 2 nuts left and 2 nuts right, which are our mounting nuts, because this rail is actually going to sit on the top and not on the front, I think. So we preloaded these. We're not gonna go and well, actually we can. They tell us that we need 25 millimeters left and right, so let's just dial that in. Dialed. And now as in the usual fashion. We just push, and we can actually check from the other side. That is pretty much perfect. And then we can tighten down the screws in the middle first. I am going to recheck after I tighten those screws in the middle. That is still perfect. That is still perfect. Nice. So I can actually torque them down. And then I want to go from the inside out. I don't want to torque them down too much, and by the way, I also usually tend to just exchange these guides to make sure that they are not biased in any direction. We don't actually need to torque these down too much. We do have Loctite in place, and if we torque them down too much, we risk stripping the threads, which until now I only managed to do on one single screw in my Z-axis is stripped. I'm guessing I'm still fine, so yeah. Anyways, that's the X-axis. We're also asked to, surprise surprise, preload 2 nuts on the bottom. As we just did. There we go. And then we get to add our axes. And I just realized that this is going to suck. Now we need the by 12s. No, these are the by 16. Where are the 12s? Give me the 12s. I need M3 by 12s. There we go. And obviously we want to not thread lock these, but some Wet n Wild is in order, I guess. Just to make sure they're not going anywhere. Nice. That is in there. And with a tiny bit of luck, the other nut is in a good position as well. So let's just top that down. And it just jumped out. Well, actually, come to think of it, why are we making our life so hard? Why don't we just they're by 6 on the bottom, by 12 on the top. So I figure we should be able to just screw these in, then get this nut started. Get the other nut started. I mean, we just need it on there. We don't necessarily need it any more stable. And we're gonna do this with the by 6 for the other side as well. If I can find the by 6 screws. Like these ones. I like these ones. These look like they can do things. And that way, we don't need to align anything. That's going to be so good. Because to be honest, preloading these and then getting those screwed sucks. So there we go. By the way, the downside of this approach is that you can potentially scratch at least the inside of your rail, and might actually not work as well. Haha. There we go. So the trick is to get them started properly. If you can't get them in there already, you may need to tighten them down a bit more. And that worked very well. Now these are in there. We have an x-axis, at least one side of it, because now we're going to do the other side with M12s, 2 on the top, and we're gonna give them a good helping of Wet and Wild here. Then put them in from the top. And I'm sure there are people going, hey, this is supposed to be, this is totally easy now. If you just do this and then that, then everything just pops in place. You go. And by the way, you tell me, because I'm very interested in how that's supposed to go. Let me zoom out here a bit again, so you can actually see what's going on. There we go. And yes, I could do this with the electric screwdriver, but I'm kind of over it right now. I know we're already way over time. I know I should actually fall over, go to sleep. Last Sunday, and by the way, it is Sunday for me already. Last Sunday around this time, I was already done clipping the whole video and was on my way to bed. But I really want to see that axis on and those in my remaining extrusions. I really want to see it. Okay, that is on there. The last nut for the day. That is so nuts. There we go. And now we're just gonna slide that on. And that felt so good. You have no idea how well that guy went. Just gonna really torque these down. And this is going to be one hell of a solid printer. There. So there. And you have no idea how good that looks to me right now. We can now check that the idlers in front and the belt path coming from the front have the same height, which they do. Lower on this side, lower on this side, with the upper coming from the back. Upper from this side with upper from here. Lower coming from the back. So that is actually perfect. Now, this is actually a good point. We may not want to screw those down all the way yet. Let's just loosen those again. And these are movable again. At least one is. The other is somewhat resistant. Well, that's fine. No. Oh no, yeah, that's fine. I just lost one of those rubber things. That's actually fine. Can take the other one off as well. Now we want to center this a bit. Move that in. Move that out until it sits snugly and centered. And we need 2x6s, in this case with 2x6, there we go. In this case again with a good helping of Wet n Wild. To screw down our x-axis. And I'm gonna move the bed mount out of the way here. Stop, we wanted to do Wet n Wild. Don't forget it. By the way, I'm kind of guessing that using nail polish is somewhat on the level of using thread locker red. Obviously without the chemical component that may potentially influence or even harm ABS parts. But here's the question. The component that harms ABS parts in thread locker, is that only in thread locker blue, or did somebody try thread locker red and have the same problem? That would be really interesting, because you know how the internet works. Ooh, thread locker doesn't work. Now all thread locker is bad. Or thread locker destroys my ABS parts. But was it actually thread locker blue or red? Or and is the component of that witch's brew that destroys or makes ABS parts brittle, is that actually in both? I don't know. You guys tell me. Again, the reminder, because I keep saying this way too infrequently. Put it in the comments, and while you're down there, like, share, subscribe. Get on the Twitter train. Follow us there. Enek is definitely gonna like that. Yeah, interaction. Any interaction helps. This, I know I'm not an entertainer. I guess you have a lot of other stuff to watch, but yeah. If you're interested in what I'm doing, if that's along the lines of what you are interested in general, or if you just want me want to see me fail here or burn down the house, I don't know. Either is fine, and I'm definitely going to do either. I do fully expect to burn down the house at some point, just because it's such an unfamiliar field of work for me. Did I strip that? No, I didn't. Did I? Oh no. Oh no. That doesn't look good. I actually sheared the screw. Fuck. I guess we're taking that one out as well. And I am hoping... Nah, that's in there. There is no fucking chance in hell I'm getting that out. That is so in there. What the hell, Fysetc? What the fucking hell? What kind of a bad screw was that? What we could do here no, so we can't actually move that. I could try to cut a channel in there. Hey Fysetc, not cool. Not cool. I didn't even have that much load on this. And it sheared clean off and directly in front of the well, basically where you don't want it. Oh, fuck me. That is so not cool. There's literally nothing to grab onto. If I can get this to turn, have to. I'm gonna show you what's going on here right now. I am going to show you what's going on. Let's see if we can get that bed further down. So you can actually see. Do you see that bolt there? That bolt is sheared clean off. Now this is an 2x6, and that M2x6 needs to now come out again. It is really well in there, and any second that we delay getting that out will result in that being stuck even more, because we put a good helping of Wet n Wild on that. So our only chance is to get some kind of channel in there, so we can take a screwdriver to it, or to get it to get any kind of grip on it. Preferably with one of these, because we can lock it out. No, that's not going to work. That is not going to work. So what I need to do now is put the desk down, because I need to sit down. There we go. And there's basically one thread left. We should have enough to grab onto that. And by the way, I'm going to use some magnification here. Some extreme magnification actually. And by the way, I have no idea what I'm doing here. I know that there's one thread sticking out. It's not enough to even, because it's an M2, it's not even enough to get anything started on that. What I can imagine is getting a channel in there, but I'm not sure what tool to use to cut that in. Well, that sucks. Everything went well so far. Maybe we can cut some notches in here. That might have done the trick. And please tell me what a stupid idea this is, and how much I'm gonna screw myself. Because again, I have no idea what I'm gonna do here. I have no idea what I'm doing here in the first place. This is all very new, all very alien to me. And I am very much winging it. That's not deep enough. And by the way, the risk here with me fiddling around with this being that I will eventually either remove too much of this bolt and lessen my chances of getting it out, or I'm gonna hurt myself, because this is very much using tools for what they are not meant to be used. So I guess you're getting your carnage finally. Again, I have no idea how I'm supposed to do this. And I did not even torque this down too much. I don't have a blade that's small enough to not just completely erase that top. I mean, not even for the drama. That may be a bad idea, but I don't know, this seems pointless. This seems very, very pointless. Yes, I am very much disappointed here. Very much not satisfied. This one screw is basically screwing me completely. I'll have to find a way to get that out. We can still, I think, mount the rest, get the whole thing set up. We're gonna just do that. I'm not gonna do belts today, that much I already said, but I'm still tempted to just doodle on the tool head, just for shits and giggles. There we go. But yeah, be very, very careful with those frickin' screws. That's definitely an experiment I will need to undertake while not on the stream. Otherwise we're gonna sit here till tomorrow. I may actually get some help there as well. So yeah, that's a bit of a disappointing ending, to be honest, but I still think we got quite far with this one. We're still gonna mount the hell out of the rest of the screws. I just know that we are going to take them out again, so I am not going to wet and wild that side. Still going to do the other one. It will mean that we need to de-rack that again as well. Too bad. Too freaking bad. This went so smoothly until now. Well, smoothly, maybe not, but I feel that it went pretty good. But without any purchase on that screw, for the moment, we're gonna be screwed. It's a good thing I still have some Ben & Jerry's in the freezer. It is a very good thing I still have some Ben & Jerry's in the freezer. That much I can tell you. Because this is otherwise going to annoy me. And annoy the hell out of me for quite some time. So some Ben & Jerry's. Some rewatching the stream on 2x speed. Adding some clips. I think that's what's called for now. That sounds like a very, very pleasant thought and a very good idea. Oh wait, this one actually needs to be thread locked. Disappointing, but that's how it goes, right? This is what you buy in for if you try to do things that you're not used to. And this is also what you buy in for if you buy a lesser quality kit. Well, in this case that actually fits. I'm not sure if this was actually my mistake. If I shouldn't talk these down as much as I am. Or if I am supposed to make sure that they sit securely. And that screw was simply bad. Alright, we're supposed to check for full range of motion. It has. So now we're getting to the last two extrusions. We're being asked to preload a couple nuts. Whoops. I guess something was hitting the space key. So we moved this all the way back. We're now supposed to tighten all the screws. Although I actually don't like that all that much, because I think the hole simply should go slightly further that direction. And now we can tighten it down. There we go. Now we need to also tighten it out from the bottom. Moving it back, moving to front, moving it back. That feels really good. That's gonna work. That's gonna work just fine. Even with that one broken screw, it's probably gonna be more than enough. But we will fix that. We will definitely fix that. Anyways, we are asked to put these in and preload and 3 nuts on the side, 3 on each. That's again for the panels, and that's went right through. So we're gonna preload 3 here. We are also going to preload 2 on the bottom for potential LED bars. Well, actually in this case we really don't need to be honest. We don't actually have any LED bars right now. And these extrusions specifically are so easy to get to. Not sure why we would. There we go. So we're keeping it. We are keeping it stock for now. Just push those in. There we go. There. There. That should do. And 3x10. and 3x10 from the back as well. Sure. We can definitely do M3x10s. There we go. That's M3x12s. That's 10s. And these are going to need some screws again. Some thread locker again. And by the way, we're not just doing the thread locker to make sure nothing shakes apart. The idea is also to make sure nothing shakes. So this should actually also dampen the movement to some degree. And I think my microphone just wants to run away. We're gonna start with the back. I will need to check on the front, but I'd rather have the extrusion already secured. There we go. That is on there. That is secure. At least those nuts are in place now. They're not going anywhere. Anything else we can deal with later. As long as those nuts can't go anywhere, we're good. And oh, yeah, that explains a lot, because we're actually supposed to take these out, then screw the back one in there, and then put them back in. Yeah, I just didn't see the arrow there. That makes sense. Wonder why we put them in there in the first place. I mean, they didn't do anything yet. Also interested in seeing what they're for in the first place, but I'm guessing it's to lock down that top head somehow. And I'm getting really tired. 8-hour stream. Wow. Over 8-hour stream. Well, but at least we got somewhere. At least we got somewhere. That one goes there. And that one goes there. Perfect. That's how I want to see it. And while we're not going to do the belt just yet, well, actually, it's not like that belt is all that difficult to do. I guess we can at least run it. And by the way, we're assuming that there's not enough, so I cut it in the middle. Not enough to run a separate second belt pass somewhere. So I basically cut it in the middle. We're just gonna mesh the teeth. Follow it until we reach the other side. I know that the end that's further from me, away from me, is actually the shorter one. So once I reach the other end, I expect that to still be the case, to see that be longer. Otherwise, I'm gonna just chop off another teeth, or multiple if they don't have the same length, because I want these to be exactly the same length. And then we're gonna real quick run the belt path.
pushing off, yeah. I ain't wanna grow up, tell her she'll show up. Funny when I glow up, single wrist is how I'm pulled up. Whipping in the beamer to the top, I'm going. Flipping my demeanor, I'm a flex, I'm flowing. They just want the quote, yeah. I've been on them road, yeah. I was born to go, yeah. They should've did the vote, yeah. Way up, feel like I'm Jordan with the layup. Shorty got me going all the way up, yeah. Way up, yeah. Way up, feel like I'm Jordan with the layup. Shorty got me going all the way up, yeah. Way up, yeah. Way up,
together, you and I. Right at your side, I lose my mind. Oh. Let it wash away. Caught on a feeling, riding
And we're here again. Sorry if you did not catch a word I said for a while. I'm not sure since when the battery of the other sender was gone. Again, I'm quite happy with the progress, even though we took ages. But look at this. Look at the face. Look at the ears. It still looks kind of rough and ready. Loving it still. Kind of nice to have gotten this far. I kind of got the belting over and done with in a hurry. Yeah. As I said just a minute ago, before I realized that people can't hear shit because the sender was out of battery for the long stream we had. Let us know if we can do anything better, if I can do anything better, if you think I make mistakes, please tell me where those are. Tell me on the Discord, tell me in the YouTube comments, let me know what's going on, let me know what's going wrong, let me know how I need to deal with that stupid bolt I sheared off that's still stuck in my carriage on the B motor side. Because I will have to deal with that, and it kind of sucks that happened, because otherwise this printer is so damn solid, you could probably roll over it with a truck. Well, no, don't think we can roll over the printer with a truck, but it is still solid as hell. Yeah, but let me know what I can do better. Let me know what you think. Please, if you're in the comments already, or if you're not, like, share, subscribe, especially if you want to join us again next week. Same time, same place, Saturday at 7 p.m. Central Europe time, 6 p.m. UK, 1 p.m. East Coast, and 9 a.m. West Coast. So join us anytime later. We're usually on for at least 4 hours. This time it was 9-ish, I think. So yeah, shit happens. I'm done. I need ice cream. I would like some whiskey, although I don't think I still have some. So can't have everything. In the meantime, take care. Thanks for playing.